Okay, so we'll continue from section 4 of the Fire Protection Handbook. Okay, and again, it is related towards NFPA 101. Okay, so you have just joined the session. Okay, so we are actually following section by okay from the CFPS examination. Okay, so we have already completed section 2, 14, 16, 17. Okay, and now we are moving towards section 4. Okay, why we are doing like this is because each and every section is interlinked with each other. Okay, so if we'll start preparing for the CFPS examination like section 1, 2, 3, okay, so there is no comparison or no interlink between the chapters, means the discussion is quite different. Section 1 is totally safety in built environment, that is totally related towards structural elements of the building. You move on towards basics of fire and science, okay, that is fire chemistry, and then third is fire investigation. So they don't have link with each other. So that is why we select the sections that are linked wise, that are internally linked towards each other, meaning that discussion is going to repeat there. So it becomes easy for us to cover more and more sections, more and more chapters. Okay. So today we are going to continue our section 4, that is human factor in emergencies. Okay. In the last chapter, in the last discussion, we discussed about the human panicking behavior, in which we discuss about the decision models. Whenever there is any type of a situation, emergency situation, okay, how the human behavior react towards the fire. So based on that, we discussed that there are various different types of decisions that is going on inside the human mind. Okay, that starts from recognition, the first stage, okay, where a person recognizes a threat. Validation, when he has enough proof that there is an actual threat. Then definition, meaning defining the threat, location of the threat, and the intensity of the threat. Okay. Then moving on, we moved on towards the evaluation stage. Evaluation meaning thinking the way out. Okay. That which is the pathway that is available for him to escape from the occupancy. Then commitment, committing to those decisions. Okay. And in the last was reassessment. Whenever your evaluation fails, for example, there is a big fire on the right side of the corridor. You have already evaluated the left side. The left side is very applicable for me. Right side is already threat. So left side, I want to escape from there, right? So you have evaluated that. You commit to your decision, but during couple of floors, okay, you find out that this exit is blocked. So there comes the reassessment stage. Reassessment means you have to reassess the whole situation. Again, go back to evaluation, then commitment. And this loop will continue unless you're not outside the building. Okay. Today, we are going to discuss about two very important concepts. Okay. In the egress designs. Okay. Moving ahead, we are going to discuss about the two very important concepts, that is how we can design or how we can calculate the evacuation time. All in all, whatever the calculations we are going to discuss here, okay, one thing is for sure, we can never ever calculate exact evacuation time. Okay, we can never calculate exact evacuation time. That is not possible for us to do that. There are various variables that will be there that will be affecting the calculation. Okay, and these variables, whenever they will be logically calculated, they will always contribute towards delay. Okay, and there are various reasons of delay. So we can never calculate the exact evacuation time. What we can do is we can always keep the time as an approximate, that this time should be available for the people to evacuate. Okay, so whenever we are discussing about the egress design, two very important parameters are always defined. Okay, one is A set, also known as available safety egress time, and the second one is R set, that is required safety egress time. Okay, so we have A set and we have R set. Okay, but what are these parameters? So let's say that, for example, I'm staying on, I want to calculate evacuation time somewhere. I'm at the farthest point of the building. I want to calculate the evacuation time, right? So what the best way of calculating the evacuation time is that I place the person on the farthest point in an occupancy, right? And then I will ask him to start the evacuation with my timer switched on. Okay, so he starts evacuating. Okay, when he comes out of the occupancy, it is 15 minutes. Let's say in 15 minutes, he evacuated from the occupancy. Okay, this is the time, exact time that is required by the person to evacuate. But the time I want to make it available for him, how much? It will always be more, right? Because I have to keep in parameter that there will be a delay. A delay could be there. So if the required time is 15 minutes, of course, I will say, let's keep 20 minutes extra. There could be any type of delay, right? So in other words, I can also say that the available time should always be greater than required time, right? The available time that I have to keep for the occupants should be always greater than the required time, right? So that is why A set is always greater than R set. That is the first way of designing or understanding the egress designs. That is why whenever we are discussing that why the evacuation time of the buildings they change, okay, they have different type of evacuation strategies just to cover up that time. Your each and everything is related towards the evacuation time. Your doors, horizontal exits, okay, NFPA3 indicates horizontal exits to have minimum of 2 hours of fire resistivity. Why? Because 2 hours of fire resistivity of horizontal exit means your doors, your walls, okay, your horizontal exits, any type of corridor, okay, they should have 2 hours of, because usually the evacuation time that is considered is 1 hour for the people in a mid-rise building, okay, high-rise buildings, it could be more than 1 hour. So when the evacuation time is more than 1 hour, the horizontal exits, you will see 3 hours to 4 hours, okay. So there are different parameters, but all in all, they all collaborate and they come towards the egress design because you want to provide a safe pathway for the people to evacuate. Okay, so that is why the time you are going to make it available will be totally depending upon the design or the time that you are going to evacuate from the occupancy. So it means I need to know the required time. Unless and unless I don't know the required time, I can never calculate the A set. Okay, so both are important in this parameter. Okay, so we have to agree on one thing, that once a person starts to travel, when a notification appliance starts ringing in any of the occupancy, like sounder, flasher, okay, when it starts ringing, okay, we've decided one thing. Once a person starts to travel, means he has already analyzed everything, and now he wants to move outside of the occupancy. That is the travel that he has started to move outside of the occupancy. So whenever he starts a travel, so there is no delay. Delay will be before the travel. Whatever the steps he is taking, okay, before the travel, okay, that all contribute towards the delay time. Okay, so whenever we want to calculate evacuation time, we usually say the evacuation time
Hello. Hello.
hello
Hello. Hello.
hello
Hello.
I think so. You have to connect to the audio. Okay, it's good on phone actually, but maybe it's talking to me. Okay, so whenever we have to calculate evacuation time, okay, evacuation time is equal to delay time plus travel time. Okay, so delay time is separate and travel time is separate. Travel time, again, I can say, is the time that is required by the occupant to evacuate, right? So delay time is the time that I'm going to make it available for the people, right? So there are different types of softwares that have different models that is used to calculate the delay time. Not calculate, but give an approximate that how you can make the delay time, how you can contribute towards the delay time. Okay, so for that parameter, we'll see that what are the important aspects, what are the important considerations that can be taken as a part of delay time. Okay, then we can add it towards the travel time. Okay, and then we can calculate how many people per second can evacuate from a corridor. Okay, from a means of egress. Okay, So continuing our discussion from evacuation time. Okay, which is equal to delay time plus travel time. Okay. Now, what is your delay time? Okay, delay time again further contributes into three very important parameters, three important times. Okay, that can be considered. The first thing is that time to notification. In the first lecture, we discussed one thing. Okay, whenever we are going to select among all the fire protection devices, detection plays a very important role. Why? An appropriate detection means a detector with a good response, okay, will give a timely notification. A timely notification means a timely evacuation. What's the use of your detector if it's giving the alarm with a 10 minutes delay? At that time, it will be difficult for your occupants to evacuate, right? So detection, a good detector means a properly maintained detector with a good response time gives you a good timely notification. A timely notification allows you a timely evacuation. So a delay in notification means a delay in evacuation, right? So time to notification, okay, one of the models. The second model is the reaction time. Once the notification has been perceived, okay, by the occupant, his reaction time is also a part of delay time. Meaning, some of the people, they tend to be hyperactive. Okay, some people, they tend to be frozen up, maybe out of paranoid, panicking. Okay, so this reaction time also contributes towards the delay time. Then comes the third important parameter, okay, for the delay time, that is pre-evacuation activity time. From the name itself, pre-evacuation activity means before evacuation, whatever the activity you are going to perform. Like for example, if you want to just collect some documents, you want to gather your family members, inform occupants. So before the evacuation, okay, whatever the activities that you are performing. And when I'm talking about residential occupancies, it seems to be a minor problem. But this problem escalates when we have mixed occupancies. Okay, where, like for example, maybe I've narrated the same example, a jewelry shop. So if he wants to evacuate, he cannot leave the jewelry shop open. He has to close all the bars. Okay, he has to lock out all the mechanism, shut it down, double, triple, whatever locking mechanism he has to completely secure it. Then he will leave. So his pre-evacuation activity time will be far more greater. Okay, so pre-evacuation activity time changes with the occupancy type, but it is also a very important factor that can contribute towards the delay time. Okay, so time to notification, reaction time, and pre-evacuation activity time. These three models are usually used to calculate the approximate evacuation time. Okay, so these three models, they change for each of the occupancy type. For business occupancies, it will be different. Residential occupancies, it's different. Okay, and there are now softwares that are working on NFPA3 So you tend to identify the residential occupancies, number of floors. Okay, and you provide an approximate distance from the farthest point towards the exit discharge, means outside of the occupancy, and it provides you the time that will be available. It gives you an constant factors. So you can just approximate, okay, 2.5 hours, 2 hours, 3 hours of evacuation time it may provide you. Okay, so they are different models, but delay time majorly contributes of time notification, reaction time, and pre-evacuation activity time. Travel time is not a part of delay time. Okay, travel time is not a part of delay time, because once you have started a travel, okay, it's not a delay. It means that you are going to move out towards the occupancy. Notification time, okay, time to notification further has three very important models. Okay, one is the DTACT model. Okay, in the DTACT model, when you select time to notification and you want to calculate the evacuation time, DTACT model, from the name itself, detection of heat detectors or smoke detectors, okay, or ACT, activation of sprinklers, collaboratively DTACT model, meaning that your model that you are going to use for the calculation of delay time is totally focused on detection and activation of the sprinklers. As I was saying that in the first lecture we discussed, the most important parameter of the material's characteristic is that I should know that what is the capability of the material. Unless I don't know that, I cannot design the detectors. My optimum performance from the detector will be from the material itself. For a wood, I cannot have class A combustibles. I cannot have heat detector here, because smoke is the very initial sign. We have discussed in the questions also, right? Smoke detectors, they are more rapid than heat detectors. Okay, so I cannot have heat detectors here in this area. If I'm going to have heat detectors here, then the heat 57 degrees Celsius will be at a time where the people will not be able to evacuate. It's over, it's end. Okay, so characteristics of the material defines the detectors. Okay, whether heat release rate, flame spread index, smoke development ratio, whatever these three values, they have priority of the other. We tend to select that detector based on the response time, right? Based on the design, based on the materials. Okay, so we select our detectors accordingly. Okay, so one of the time to notification model is DTAC model. DTAC model, they can ask in the examination also. Okay, they can ask you that which type of a model refers towards the delay time of the evacuation time. So they can further collaborate and they can provide you DTAC model. It is in the handbook. Each and everything is in the handbook. We are not going above handbook. Okay, look, these things are those things that define NFP 101. Section 4. Okay, chapter 3. Yeah, concept of egress design. Okay, so these sections, okay, these topics, they define the code itself. In NFP 101, they will not tell you time to notification or detect. They will just simply say you that this refer to this, and you should add 2 hours. So where this 2 hours is coming, we don't know. So what are the challenges? The challenges comes, okay, when we face a new type of a challenge, and that challenge the NFP 101 does not answer, right? So you have to come back to the basics to understand that how I can create a new way. Okay, so that is why the fire protection handbook is introduced as a course for a CFPS, fire protection specialist. So one of the model is the DTAC model. Okay, the second model for time to notification, okay, is the break model. The break model is usually authorized, or it usually activates whenever you have any type of a manual pull station, manual call point. Okay, because yes, MCP, okay, it can be used to create notification appliance. Sometimes your detectors are not operating. Sometimes your detectors are not able to sense the danger, but your eye is able to sense it. So you want to create a notification. So break model is also there. The third type of time to notification, okay, model is FDS, the fire dynamic simulation. Okay, fire dynamic simulator. Fire dynamic simulator provides you the response of materials, heat, and smoke movement in a building. Okay, so nowadays in the universities we have a simulation. Okay, a simulation program creates the same occupancy. They tend to put on the materials, okay, and they start an ignition source. All is done as a simulation, and then they tend to identify where the initial heat and smoke is going to go, and then they tend to provide you the information where you can place your detectors. Okay, so that you will get a good response, okay, effective response. Okay, and where you need the barriers, smoke barriers, fire barriers for vertical protection and horizontal protection also. So for that purpose, fire dynamic simulation is also used to provide you time to notification. Exactly. Okay. So in examination, they can provide you any of the question, they can twist it around. Okay. Like for example, they may simply ask you DTAC model follows to which type of an time model. It gets delay time, in delay time to notification. Or they can ask you which of the time is not a part of delay time. And they can give you time to notification, reaction time, pre-evacuation activity, and travel time. So travel time is not a part of delay time. So like this, they can always twist the questions in the examination. Okay. But when we are saying travel time, when we are saying that travel time is not a part of delay time. Why? Because we have already started travel towards the exit discharge. But is the travel time equal to required safety egress time? Not possible. Why? Because in travel time also there is challenges. I am healthy, I can evacuate much more quickly. Okay. 3 months back, I was healthy. God forbid, today I have an injury. So I have to, whenever a designer is actually the hazard recognition specialist, whenever he is designing the egress, he has to keep all the parameters intact. In the previous lecture, we were discussing about the disabled occupants also, right? And that is the scenario that we have to always keep in mind. Okay, whenever we're talking about residential occupancy, so it's not only the healthy occupants that we have to consider, we have to always consider for the disabled occupants also. Okay, how they are going to evacuate. Similarly, 3 months back, I was healthy. Now I'm not that much healthy. Maybe I have some type of injury and my movement is slow as it was not. So it means in the travel time, okay, there could be a delay also. Okay, but we don't consider it as a part of delay time. Okay, there are parameters that can affect the travel time also. So travel time explains the required safety egress time, but it is not equal to required safety egress time. Okay, there could be challenges that can affect the movement. Sign location. Okay, some people, they may not be able to locate the signs during panicking behavior. In the last lecture, we discussed about one thing, the exit light color, right? And we discussed the exit light can be either green or red. Emergency exit, it can be green or it can be red, right? It can be green and it can be red. It's not like that the code says it should always be green. Okay, why? The green, why? Because if this is a green wall and I'm having a green exit light, the color matches. In panicking, I will never be able to differentiate between it, right? So the only condition is that I have to always make sure that there is a contradiction. Okay, so that in panicking situation, I will always go towards the color, human nature, that is different from the surroundings, right? So for that purpose, locating the signs could be one of the reasons. Operation of doors could be one of the reasons. Okay, so there are various reasons that can affect the travel time also. So I'm not saying travel time is equal to the required safety egress time. I'm just saying we can define required safety egress time by travel time, but it's not equal. Okay, there will be challenges in the travel time also. Okay. But travel time can be calculated up to a point where we can estimate it, that how much people per second can evacuate. Okay, so if I want to calculate the travel time, okay, just for information, we are going to use this one. Actually, calculations are not part of the examination. Okay, formulas up to a point where they want to define any terminology is only used for the examination purpose. Okay, calculation that we are doing here is just for understanding purpose. Okay, they can use any, like they can say that, for example, for the travel time, we have one formula: flow is equal to speed into width into density. So they can simply means they can say that flow of a person, movement, depends upon which factors. So speed, density, flow, speed, density. Okay, means people movement totally depends on flow, speed, and density. Okay, so means of egress, width will be included. Okay, movement is totally depending upon flow, number of people per second, at which speed they are traveling, and depending upon the occupancy they are covering. Okay, so each and every terminology here has a unit. Okay, so if I want to calculate density, for example, okay, it is people per square feet, square meter, you can say. Okay, so for example, if I want to say that I have density, okay, so I have 500 people over 1000 square meter of an area. Okay, so what will be the density? 0.5, right? So it's going to be 0.5 persons per square meter. Okay, width, what is the width? Width of the means of egress corridor. Okay, what is the width? Okay, so standard width, let's say it's 1 meter. Speed, average speed of a person varies from 0.8 to 1 meter per second. Okay, 0.4 to 0.8 meter per second, but in panicking situation it can go up to 1 meter per second also. Okay, so let's say that it is 0.6 meter per second. Okay, so I can calculate flow from here. Okay, it's going to be 0.6 multiplied by 0.5. Okay, and it's going to be persons per meter square, and per second. Yes, meter square. This is also meter square. Okay, so what will happen? We will have here meter square per second, right? So it's going to be 3.0, right? Meter square cancels out. Okay, persons per second. Persons per second. I can calculate. It means I can say that, okay, this is 3 persons per second. Now, in 60 seconds, how many persons can evacuate? It's 180 persons can evacuate from an occupancy. Okay. Now, this type of model is also known as capacity model. Okay. This, if we are going to use the calculations, we focus on the capacity models. Okay. Meaning that we perform exact calculations based on the occupancy. Okay. But these calculations are not applicable everywhere. These type of calculations, they are not applicable everywhere. Why? If I'm talking about a residential occupancy, okay. Dubai Mall, it's not going to apply. Okay. Global Village, it's not going to apply there. Okay. There, it's not going to apply this. We are not going to apply this there. Okay. Why? Because crowd is too much. Okay. So there, we tend to move on towards the next strategy. Okay. So that is the movement models. Okay. We will discuss that also. But travel time can be calculated like this. Okay. And this is usually said that the means of egress can be calculated by two ways, two models. Okay. One is the capacity model, and this is the capacity model. This also defines capacity model. Flow is equal to speed into width into density. That is capacity model. Okay. The second type of a model, okay, is the movement model. We will discuss that. What is the movement model? Movement models are usually defined, or they can be always calculated in those occupancies where I have too much amount of crowd, where I cannot focus people on one width of a corridor. Okay. For example, if there is any type of a threat in global village, okay, so what I want, whatever the means of exits I have, I want all the people to evacuate. I will open all the pathways, right? So that a maximum people can evacuate, right? So that is, but how much amount of people one door can occupy, that I need to know. Okay, that is the movement model. We'll take one example as per the NFPA design. Okay. In the movement models, okay, what we tend to do is that, and we follow the NFPA codes. Okay, NFPA says in the movement model, each and every door has a capacity. Each and every door should have a capacity. Means I will open a big door. Okay, but that doesn't mean that all the occupant load I will punch in one door, right? It's going to be a bottleneck. Okay, a stampede situation will occur. Okay, so each and every door should have a occupancy load, and the people that are assigned to provide the directions to the people, you see usually the securities, they create barriers, okay, block the pathways, they direct the people in different directions. Okay, so that more people are not at one location. So movement model example is like, for example, NFP 107 says if you have 3 doors that are available, okay, each and every door has one occupant load. Okay, let's say you have total 450 occupants. I'm just saying, take for example, okay, one door has the capacity, each door has the capacity of carrying 150, 150. What should be the capacity of the third door? 150? Anyone else? We have to always consider a worst case scenario. More than 150. Why? Because if one door is blocked, where these people will go? So one door should always have double the load. And this door should always be well protected. If you know that this door is the door that is going to accumulate my people, okay, it should be having higher smoke and wall ratings, sprinkler protected, appropriate detection, okay, all emergency responders, your first responders, they will first of all make sure that this door is always free of danger. Okay, this door is not affected. Whenever there is a threat, the emergency responders are given 2 directions. One, they always respond to the threat. The other team always respond to this area. Okay, they always want to make sure that this area is always free of any danger, so that they can evacuate large people in shortest possible time. Okay, so that is this is again as per the NFPA. In the NFPA 101, if you'll open again NFPA 101 section 7 chapter 2 means of egress, you will find out only that one door should always have the capability of maintaining more than the occupant load of the other doors. Okay, so it's only defined it there. Okay, but explanation is like this. Why? Because if your one door is blocked, okay, so your other door should always have the capability to move out people. So here we are not discussing about any calculations. Okay, so this is the movement model. We want to move people towards different doors where we have double load, so that we can evacuate people accordingly. Okay, this is the movement model of the means of egress design. The third type of a design model, okay, that is available for the means of egress is the behavioral model. Okay, behavioral model defines the common behavior of the people. Okay, like for example, if I'm talking about disabled occupants in one occupancy, that is, let's say, healthcare occupancy, hospitals, they all have a common behavior. They all require the assistance of other people to evacuate. People who are on stretchers, who are on wheelchairs, they have a common behavior. The common behavior is that they cannot evacuate themselves. They need the assistance of other people to evacuate. So your means of egress design will change in the behavioral model, because the common behavior is that they all require the assistance of other people to evacuate. Similarly, your detention facilities, prisons, jails, they have a common behavior. The common behavior is that in emergency, you cannot allow these people to move into the public way. You cannot evacuate them. The common behavior is that you have to provide you can say a secondary containment within the facility. That is the common behavior. They are non-law abiding citizens. Okay, so you cannot allow them to evacuate. So that is the common behavior. Okay, so you tend to identify the common behavior, and based on that, you change the evacuation type. Okay, so whether you want to have a total evacuation, partial evacuation, defend in place strategy. Okay, so whatever the strategy you want to have, first of all, you need to identify the behavior of the occupants. Okay, so means of egress design can be categorized into three models: capacity model, flow is equal to speed into width into density. Then we have the movement models, defining how much amount of people can evacuate per door. Okay, and the third one is the behavioral model. So whenever you have a healthcare occupancy, the egress design is always based on the behavioral model. Okay, egress design is always based on the behavioral model. Whenever you have large occupant areas, festival areas, okay, big malls, okay, so these all, they are always designed on the movement models. Okay, and whenever you have residential occupancies, okay, small industrial occupancies, okay, any type of research laboratories, okay, so they all are designed on the capacity model, where you know that I have limited amount of people available, and the cost is also you have to make sure the cost is also less. So based on that, you tend to follow the capacity model. So these are the three types of means of egress models that we tend to always follow. Yeah. Oh yeah, sure. Oh yeah, no, sure. Sure, no. Okay, thank you. Samir. Nice to meet you. Okay, let's move on towards NFP 101 basic requirements. Okay. Okay, NFP 101 basic requirements focuses on the life safety aspect of the people, right? So it always focuses that there should be some very important parameters that should be always available, okay, for the people to for the first thing about any fire protection device is the evacuation of people, life safety of the people. Okay, that is the first primary goal that we always want to achieve. So NFP 101 has some very basic guidelines, okay, that focuses that there should be enough means of egress, okay, that should be available, okay, for the people, unobstructed means of egress. I'll just define some of the important ones. Okay. Properly illuminated areas. Okay. A well-maintained fire alarm system. A well-maintained fire alarm system. Okay. Then proper marking means of egress. Proper marking of the means of egress. Okay. And then protection of means of egress. Protection of means of egress. Some basic, there are actually a lot of parameters on which NFP 101 is there. But whenever we are talking about residential occupancies, okay, so the basic parameters are the one that tends to evacuate people in the shortest possible time. But NFP 101, whenever we are talking about the basic requirements, it says that the first important parameter is the interior finishing. Okay. And if your interior finishings are controlled, it means your flame spread index values will be controlled. Okay. If your interior finishes are not having flammable materials, flammable walls, flammable interiors, okay, then these all parameters will be affected. So what NFP 101 does is that it says that, okay, the contents that you are going to store within the occupancy can be categorized into 3 contents. Okay, so let's say hazard of contents. It defines 3 hazard of contents. One is the light hazard contents. Then we have ordinary hazard contents. And the third one is the high hazard contents. Okay, so the contents that may be available in any occupancy. Okay, light hazard contents are those contents that have such low combustibility, okay, that no self-propagating flame can occur in them. Same like furniture, okay, there no self-propagating flame can occur in them, right? Then we have ordinary contents. Ordinary contents that have contents that may burn with moderate rapidity. Okay, so low combustibility, no self-propagating flame may occur. Ordinary combustibles, ordinary contents that may burn with moderate rapidity. And high hazard contents that may burn with extreme rapidity. The hazard of contents can be categorized into 3 types. Again, NFP 101, the focus is the hazard of contents. And why it's the focus? Because on the contents only, you can always provide the other parameters. If the parameters of the contents are high hazard, extreme rapidity, burning with extreme rapidity, your other parameters all change. They all change accordingly. Okay. Let's move on towards interior finishes. Okay, interior finishes of as per the NFP 101. Okay, guidelines. Interior finishes. Okay, as per the NFP 101 guidelines. Okay, the flame spread index of any interior finishes should be categorized from 0 to 200. Okay, and we will discuss why it's 0 to 200. What are the classes in the flame spread index? But it should be always from 0 to 200. From the terminology itself, it's an index, a scale. Okay, 0 to 200. And the smoke development ratio 0 to 450. Maximum up to 450. When we are talking about a flame spread index, meaning from the name itself, okay, the amount of flame spread over the surface of the content that is available. Flame spread index can be categorized into 3 classifications. We have class A flame spread index, class A materials having a flame spread index of 0 to 25. Okay. Then we have class B flame spread index. That means that a material can have flame spread index from 26 to 75. Okay. Class A and B, they are meaning they are good flame resistive materials. Then we have class C materials, okay, that may have flame spread index from 76 to 200. Okay, now these are very important. Why? Because when we'll be discussing in the building services about the elevators, in the elevators, NFPA 70 will indicate that elevator should have should be made of, the elevator car or elevator cart should be made of material that may have a flame spread index from 0 to 75. 0 to 75. It means the material should be class A, B material. Okay, means class A or class B material. Okay, any you can use. Okay, so when it says 0 to 75, it indicates class A, B materials. Okay, class A or class B materials. No, it's an index, a scale, means the flame spread over the surface area. So class A means a very good flame resistant material. B means a little bit less. C is much more less. So it's an index, it's a scaling. Okay, so class A, B materials. Okay, so whenever a material is being provided, if you go towards a technical data sheet, it will provide you a fire resistant material, will always provide you information what type of material it is categorized in. Okay, so it's, if it's indicating class A, it means it's a very good flame resistant material. Okay, and if B, again it comes out into a good one. C is considered to be the average material. Okay, it may have comparative more flame spread, but not more than that. Okay, more than C means that the material is highly flammable. Smoke development ratio of any material should be 450. This is also an index or scale value. Okay, and it should be 450. 450 indicates that up the material's capability of providing 450 means that it still provides enough visibility for the people to evacuate. But if it exceeds more than 450, it's more like more black dirty smoke that is appearing. Okay, that a material is capable of giving more black dirty smoke. Okay, so like for example semiconductors, laptops, computer shops, okay, where they have too much PCBs, so whenever they burn, or tires, plastics, okay, rubber industries, whenever they burn, they tend to give off black dense smoke. So it exceeds the smoke development ratio. So whenever it exceeds the smoke development ratio of 450, it means that they need to provide an appropriate measure so that they can evacuate the people in a timely manner. Okay, so that is why in the interior finishes, NFP101 says that a maximum smoke development ratio should be up to 450. Okay, again, a value of scale, meaning that amount of smoke that it's being releasing with the cryosites that it's producing, okay, over the area. So the scale is up to 450, means up to 450, a clear visibility is there. Okay, but above 450, a black dirty smoke will be can be expected, means the more denser, more black dirty smoke that can affect the visibility as well as it can affect the evacuation also. Okay, so interior finishes, flame spread index and smoke development ratio we have discussed here. Okay, so in the examination they can ask anything from there. They can even ask you about a class B flame spread index values. Okay, this the same information we will find in NFP 101 section 10 chapter 2. You'll find the same information that is available regarding the interior finishes of the NFPA 101. Okay. Okay. Okay, your furnishing and decoration. Your furnishings and decorations. Okay, so your furnishings and decorations, okay, they have a flame spread index values. Okay, they have amount of radiations they can emit per unit of an area. Okay, like for example, if I'm keeping this table here, it has the capability of releasing energy. For section 2 we discuss amount of energy that can be released is watts, right, per meter square, right? So each and every component has the capability of releasing energy per square of meter. Okay, so NFP101 make sure that whatever the furnishings you are having, it can have two types of classification. Either you can have a class 1 materials, okay, that will provide you 0.45 watt per centimeter square, 0.45 amount of energy released per square centimeter, okay, or class 2, okay, where I can have 0.22 watt per centimeter square. So in both cases I can use any of these classifications, but in the examination they can provide you a question, okay, like for example, for sprinklered buildings, the buildings that have already sprinkler protection, okay, so which classification will be used for sprinklered buildings? Remember one thing, NFP101 focuses on both of the designs, new and existing buildings, okay. So for sprinklered buildings, which classification will be there? Sprinklered buildings, class 1. Why? Class 2, class 1 we can have class 1, yes. Why? Because the building is already protected by sprinklers, okay. Class 2 having a very limited, actually uh, someone has written anyone also, yes, you can have both, but usually class 1 is classified for sprinklered buildings, class 2 is classified for existing buildings, non-sprinklered buildings. So you can have limited amount of energy release, right? Because there are some existing buildings that don't have sprinkler protection. So NFPA 101 keeps in consideration both. Okay, usually class 1 is classified because if I'm saying more amount of energy release per unit of area means that the product's price is also less. If I'm providing more resistivity, it means coating is there, flame retardant is there, resistivity, I'm increasing it, so the price also increases. Okay, so that is why basically we classify class 1 as those type of materials that can be used in sprinkler buildings, no issues, you have sprinkler protection there. Okay, so for non-sprinklered existing buildings we have to go for class 2, we have to limit the amount of energy release per square centimeter, and this release is there so that we can evacuate people again in a timely manner. So evacuation is much more quicker. Yes, response time index and these two parameters, they really affect these values. Okay. Means of egress. Means of egress can be, has three very important portions. Okay. The first portion is exit access. The second portion is exit. And the third portion, okay, is exit discharge. Exit access is considered as the pathway that leads towards the exit. For example, I'm standing here, any type of alarm comes, so I'll be using the hall, corridor, stairways, and then moving towards the main hall of the building. So this all is exit access, the pathway that is leading me towards the exit. Okay. Exit of the means of egress is considered from where the exit has to be made. Okay, it separates from the part of the building. Okay, exit has to be made. It could be the main door of the building. Okay, the main door of the building, that is exit. The component itself, okay, is the exit. It could be main door of the building, it could be the window of the building, okay, from where the exit has to be made. Okay, so that is the exit. Then comes the third important component, that is exit discharge, meaning when you move out towards the public way. Okay, completely isolating yourself from the building outside in the public way. Okay, so the footpath near or opposite a street, that is your exit discharge. Okay, so these are the three components of the means of egress. In examination, they can define any of the component. Okay, usually the confusion comes when they are defining this, and people they tend to think it's discharge because it's separating from the building. Okay, actually, when it's saying separating from the building, it means that it is separating you from the building. A component of the means of egress that is actually separating from the building, meaning it is separating you from the building. Okay, so that component is exit. So just focus on the punch words. Okay, whenever the definition is there, whenever it says a pathway in the whole definition, it means it's exit access. Whenever it says the component separates you from the building, okay, that is exit itself. Okay, and the public way, exit discharge. Okay, so all the definitions, they, because there are, these are not the only definitions. In NFP 101 you will have variations. So they have like, they want to define one component, they have given like 5 to 6 lines to define that component. So once you start reading it, so there are multiple definitions. Okay, but the punch words are always same. Okay, so if these punch word comes, that it indicates that it is actually defining towards the exit discharge, exit, or exit access. Okay, wherever the pathway is there, it is exit access. Okay, whether it's leading its door, because in the pathway also you have doors. Okay, room doors, stairways doors. Okay, so all these are there. Horizontal exits are there. So these are our components of exit access. Exit is the portion from where you are going to make the exit. Okay, discharge whenever you move on towards the public way. Okay, outside, completely isolating yourself from the building. So that is your exit discharge. Okay, so we'll discuss about various types of means of egress. What are the means of egresses, components of means of egress? We'll see doors, stairs, horizontal exits, okay, escalators, moving walkways, elevators. We'll discuss all these components. Starting from doors. Doors, they are categorized into 4 types, okay. We have manual doors, okay, doors with magnetic poles, we have doors with automatic closures, and we have doors with delayed releasing devices. Manual doors, when you open them, they remain open. This is a manual door. You open it, it will remain open. You close it, it remains closed. Magnetic poles usually have a floor mounted magnetic pole. When you open the door, it sticks, it remains open. If you have to close it, you have to apply a little bit force to close it. Automatic closure, on the top of the door, we have the automatic mechanism. We open the door, we just move away. Automatically, slowly it will close it, okay? Doors with delayed releasing devices, DRDs, okay? DRDs are usually considered as those doors, okay? They are usually available for those areas where we don't want unauthorized personnel to enter, okay? Now, it could be in healthcare occupancies, let's say, in hospitals. In case of panicking situation, okay, we don't want people to enter into the ICU rooms. When they are panicking, but they will find any pathway that is open to you, they will rush there, right? But you don't want them to enter into towards critical patients area, right? So they are always protected by delayed releasing devices. In other words, we usually say a specific access control is required to open those doors, okay? So delayed releasing devices. Similarly, airport terminals. In case of emergency, you want all the people to evacuate outside the facility rather than people running on the runways, right? So those all areas will be isolated, sealed off by DRDs, okay? Delayed releasing devices, okay? Now, delayed releasing devices can be operated in 3 ways, depending upon the nature of the incident. It can be operated in 3 ways. Whenever there is any type of a power fluctuation, electrical failure, okay, the delayed releasing device can be activated. Whenever there is fire alarms, fire alarm control panel also, you can integrate the doors with them, right? And we have seen a lot of places the fire panel is integrated with the door itself. As soon as there's a fire panel alarm, it can be deactivated, de-energized. But each and every emergency is not related towards fire or power, okay? Sometimes there are some emergencies that requires human interaction also. Means any type of bomb threat, any type of false information where people want to evacuate. So DRDs can also be activated by force. If 15 pound of force is applied for 15 seconds, these doors will de-energize. Okay, they can be de-energized in that way also. But it depends upon the facilities which of the de-energizing method they want to apply. Okay, so delayed releasing devices can be activated in these 3 ways. Okay. Doors, they are considered as means of egress, right? They are considered as means of egress by NFPA3 means. And whenever we are saying a component is a means of egress, means it can be used as means of escape. Means we use doors to escape from the occupancy. The second means of egress component is stairways. Stairs. Okay. Now stairs, NFP101 says that stairs can be considered as means of egress. Yes, we can always use them as means of egress. But NFP101 says that the best dimension for a stair is that it should have a 11-inch tread, okay, and a 7-inch riser. Okay, these are the best dimensions for the stairways so that people can evacuate. Okay, why? Because if I have tread less and riser more, it will be something like this, more riskier. Chances of slipperiness is much more, right? So that is why the NFP101 says the tread should be 11-inch and 7-inch of riser. So this type of these dimensions of stairways are very effective for the people to evacuate very easily without causing any slipperiness or injuries. So stairways, they are also considered as means of egress, right? Then comes the third component. Horizontal exits. Various ways in which we can define horizontal exits. Usually, okay, a pathway from one portion of the building, okay, that leads off towards the other portion of the building. Okay. One pathway leading towards the other pathway of the building. So this all portion is actually the means of horizontal exit. Okay. So horizontal exit, NFP101 says should be minimum protected by 2 hours of fire resistivity. It should be minimum protected by 2 hours of fire resistivity. So horizontal exits, okay, they are also considered as means of egress. Ramps, various different chords are there for the ramps, and the inclination should be rated up to such specific point where the wheelchair can be usually used effectively to evacuate the people, okay, outside the occupancy. But the ramp should always have resistance strips. Why? So that we can stop the wheelchair anywhere in between and the person does not slips away. Usually on the stairways also at the ends you will see there are usually strips, okay, that provide grip, stop. So ramps are also considered as means of egress. Any type of exit passageways. Okay, like over tunnels, okay, overhead bridges, okay. So they are also, you'll see that most of the time we have subways that are available, okay. So they are also considered as means of egress. Why we are mentioning each and every component as means of egress? Because moving on, we will discuss about other components that are not means of egress. Okay, so in the examination, they may provide you a question that among these components, which are means of egress, which are not means of egress. Okay. These components, they are means of egress, means of escape. They can be used in case of means of escape. Then we have fire escape stairs. Okay. So usually you'll see that most of the some facilities, okay, they don't have internal staircase. So they have one staircase at the external of the building, right? So these are fire escape stairs. Okay. In existing buildings, okay, we don't have any other option, so it's fine. But in new buildings, they are not considered as means of egress. They are not allowed, okay, to be constructed, okay. In existing buildings, if it's there, so it can be considered. In new buildings, it's a very poor substitute by NFPA 101 as a means of egress, okay. Then we have escalators, okay, inclined people mover. They are also not considered as means of egress. Moving walkways, okay. Horizontal people mover. Usually in airports you'll find out, right? So they are also not considered as means of egress. Escalators, elevators. They are also not considered as means of egress. Okay. Hmm? Yeah, fire lifts. They are still not considered as means of egress. For us, it's not. Firefighters want to use it, they can use it. For us, it is not a means of egress. We cannot escape from there. Firefighters elevators is only for firefighters if they want to use for escape. For us, we cannot use it. So these are components which are not means of egress. They are not considered as means of egress. Yes, for disabled people, they have firefighters elevators. Again, they want to use it. If you want to make evacuation from elevator, okay, so it should be pre-planned. Okay, pre-planned means that your shafts are pressurized, your components are water resistive, you have sprinkler protection, your cart is AV material. Okay, so it's pre-planned. So mostly elevators are not considered as means of egress. We itself, we cannot use it as means of egress. Okay, firefighters elevators, they are not considered as means of egress for us. Only they can use for escape. Okay, got my point? Still, even if it's a firefighter elevator, for us it's not a means of egress. For them, they can use it, and they will also use it whenever the conditions are favorable for them to use, right? So elevators, escalators, why we don't use them as means of egress? Any specific reasons? Fire escape stairs, very it's I mean obvious. Why? Because if you are evacuating from bottom, anything can fall from top, or fire can break out in the middle. Of course, you cannot escape, so you get trapped there, right? So because whenever there's a closed compartment, window breaks, a big pressure of flame comes out. Okay, a vortex of smoke may come out, flame may come out, so it becomes difficult for you to escape. That's why fire escape stairs are not considered as means of egress. As per NFPA3 it's a very poor substitute for means of egress. Escalators. If it stops, we can access, but the problem is that we cannot access. Why? Because it's a mechanism and there is no vertical protection. The vertical protection is not there. Okay, so if you will consider as a staircase, the staircases, they have vertical protection. The flame cannot propagate and come towards the stair in between the treads, right? But the escalators, whenever they open up, there's an opening. So if you considered it as a means of egress and there's a fire there, it means your one means of egress is blocked. Okay. So once you consider this as a means of egress, it means that you can remove two building stairs also. You got my point? So if you want to have a staircase and you and an escalator, okay, you are thinking, okay, one staircase and one escalator of means of egress. But this escalator is a means of egress that is vulnerable towards vertical openings. If there is any type of fire at the bottom mechanism, it is blocked. So that is why it is not considered as a means of egress. Better have another staircase there. Don't depend on them. Similarly, moving walkways also same. Vertical protection is not there. The mechanism, the flame may propagate. Okay. In staircases, normal building staircases, they have very good fire resistivity. Okay. It provides a safe pathway for. Yes, the belt inside, any type of mechanism that is opening. Okay. And another parameters also, the escalator materials also, if it heats up, you cannot step on it. Right. So in that case, they are not considered as means of egress. Elevators, same. They also have no vertical. They also have no vertical protection. They usually have openings. Stairs. Yeah, you're building stairways, concrete at the bottom, no? Right? It's completely sealed up. So between the tread, nothing is coming up, right? So in between the tread, nothing is coming up. But in escalators and moving walkways, because the belt is moving down, so there is an opening there. So wherever there is an opening, there's always a chance it's going to block. So if I'm going to design means of egress, I will not include them because they are vulnerable. Anytime they can compromise my escape. Elevators, one of the most fast moving way, okay, outside the buildings, but they are not considered as means of egress, right? Why? Reasons? What are the reasons? Horizontal services? Okay. Horizontal shafts, okay. Elevators, various reasons, okay. The first reason is that your elevators, okay, first of all, it has no backup power. In case of fire, the first thing is that the authorities' power will fail out. The elevators will hang. Second reason is that elevators can carry only a specified amount of people. Okay, you cannot overload it. Okay, means if you're going to overload it, so it will stop. Okay, third reason is that a person is already on a fire floor and he calls the elevator. Elevator will come to the fire floor, exposing other people also towards the danger. Okay, so that's why other reasons are also there. Like for example, if smoke accumulates in the shaft, so elevator will move up, it will take smoke to other portions of the building. So it may help in propagate the fire spread. So that is why elevators are not considered as means of egress. Okay. Yes, vertical opening. Okay, door opening outside from the building on the grade level is considered as an exit. Okay, so look, if you're we are talking about a door opening, okay, from the outside from the building, okay, on the grade level is considered as exit and exit discharge, okay, both or not, okay. There's not a direct answer towards this question, okay, because just keep in mind as the same purpose, okay, anything, okay. That's why I didn't focus only on the doors itself. I mentioned windows also. Anything that is actually a component that separates you from the building itself, okay. So if a door that is opening from the outside of the building, okay, either it's on the grade level, okay, but it is taking you outside of the building, means it's separating you from the outside of the building, it is that component is known as exit. Okay, so exit discharge is not any type of a component. Okay, exit discharge is actually, you cannot say it's a material itself. Exit discharge means that your position into the public way. You are standing on a footpath, okay, in the streets, completely isolating yourself. That is exit discharge. So when you're talking about a component, it is exit. Okay, so any component that is actually separating you from the building means that you open the door, you open the window, you move out. Okay, so that door and that window, that material itself is the exit. Okay, but exit discharge is the position, your position that is completely isolating yourself outside of the building, that is in the pathway, in the public pathway. Either it's on the footpath, it's on the street, across the street, but you are in the public. Okay, means you are not nearby to any component of the building. So that is the exit discharge. Okay. Yes, forms vertical opening, draft, chimney effect. Yes, these all are majorly vertical openings, we usually say. Chimney effect is also because of the limited amount of opening that is available. Okay. And that can cause the escalators to be not a part of means of egress. Elevators. Okay. Okay, so in the examination, they can also ask you about, they can add, means they can add windows, ropes. Okay, so ropes, they are considered as means of egress. Firefighters use ropes, right? Ropes are used by firefighters for escaping, right? But for people, it's not. Okay, so when we'll be discussing about the ropes, that is in the organizing fire rescue operations, okay, when we'll be discussing about ropes, that rope should have a fall factor of 0.25, okay, meaning that the failure of the rope, okay, per per distance, we'll see how we can calculate the fall factor of the ropes. So ropes, they are using in the organizing fire rescue operations. In fire rescue operations, that ropes are different. Okay, but when you're talking about NFP101 and ropes and means of egress, so when a means of egress comes, it means it's occupants involvement. Okay, so like firefighters, lift is firefighters component. Okay, means of egress, when it's asking me elevators as a means of egress, even if it's a firefighter elevator they are mentioning as a means of egress, for me as an occupant, it's not a means of egress. Okay, ropes are not considered as means of egress. Okay, windows, they are not considered as means of egress. For me, it is not considered as means of egress. Now, if you'll see that most of the time, the hotels with the balconies, they have the highest rates. Why? And they are always reserved. The hotels with balconies, they usually have highest rates. They'll say mountain view, sea view, but usually whenever there's a VVIP person, a diplomat, they are always given rooms with balconies. So that in case of emergencies, if they want to make an escape, okay, they can be escaped from the aerial ladder from the balcony. Okay, the enclosed rooms are the most dangerous rooms, means in case of fire. Okay, smoke is trapped, you are trapped inside, you want to move into the corridor is completely occupied with smoke. Balconies, you can open it up, you can stand in the balcony, you can call for help, you can escape from there. Okay, so various reasons are there, so that can help you in escaping from the occupancy. So usually whenever there is a diplomat or VVIP personnel, the balcony rooms, okay, they will always be reserved, okay, for these people, so that in case of any emergency, they can be escaped from the aerial. And that's why their rates are also usually higher. Windows, ropes, they are not considered as means of egress. Okay. Egress lighting. What should be the egress lighting? The minimum, the egress lighting, 1 foot candle, or it can also be written as 10.77 illuminations per centimeter square. Sorry, meter square. Sorry. Yeah. Yes, meter square. Lux per meter square. Okay. So 1 foot candle. Okay. Minimum illumination. Usually the illumination is 7, 8 foot candle. It can go up to 10 foot candle. But when it says 1 foot candle, okay, measured at a floor, it means that when your battery is completely about to discharge for the egress lighting, okay, the minimum illumination it should be providing is this much when the batteries are completely discharged. Okay, so 1 foot candle. Okay, and the most important thing, sometimes they ask in the question, and in the sample questions also you will see that they have given this in the answer. Okay, and they're asking other options like egress lighting should be measured. Egress lighting should not be less than 1 foot candle, and they will give you 4 options: measured above the floor, beyond the floor. So whenever we have to do a measurement for I, it is always at floor level. Okay, lighting or anything, okay, that is in the site. Okay, so it is always at the floor level. Above or beyond, it has no concept of measurement. So it is always measured at the floor level. Exit signs, we have discussed already, right? Exit signs, green or red, it could be both. But the only thing is that it should not contradict with the interior colorings, right? So if it's green coloring, green interior, I will have a red emergency exit sign. Okay. So if it's red interiors, I will always have green. Usually we have green type of exit lights. Why? Because usually our interior is white. Okay, red carpeting. So the green one provides a distinguished color. So in case of panicking situation, people will always go for a distinguished one so that they can escape. Your fire alarm control panel is again an important component of means of egress, and it should be well maintained. Okay. What is the most important component for alarm control panel to be maintained? Most important and the first component that needs to be checked during maintenance. Yes. Fire alarm control panel. We have discussed about the fire alarm control panel's maintenance, components, right? Which is the first component and the most important component of a fire alarm control panel that should be maintained? Exactly. Secondary power supply. The batteries. The secondary power supply. Okay. Because in case of fire emergency and fire, the first thing that is going to cut off is authorities, right? So once it's cut off, your whole system will be running on the batteries. No matter how much expensive unit you have, how much effective unit you have, if you don't have a backup, it's zero. Nothing is going to run. Your annunciations, your detectors, notifications, everything is dead. Okay. So that is why the first component of our alarm control panel is that you have to check the batteries. Usually when I go for the maintenance for the control panels, the first thing I do is that I cut off the power supplies. The authority power I cut off. I do my all testing on the batteries, because your batteries should be capable of carrying all these loads of those notification appliances, your sounders, everything. It should be capable of carrying. So if it's not carrying, no use. So people, they go, you'll see quite professionals, they will go, they will just clean the detectors and leave away. They will just check the detectors and go. They will switch off the control panel, okay, for 5-10 minutes, but they are not testing anything. You are not putting any load on it, merely LEDs. So how do you know the battery is going to perform? Okay, the first thing is that you switch off your power supply, then do all the testing on the batteries. Then you will know whether the battery is capable of carrying that load or not. Let your sounders, your flashes, your detectors in operation condition, let it run on the batteries. Okay, so just 5 minutes. So moving on. Okay. So moving on, we were discussing that there were some occupancies, okay, where crowd is too much, right? So crowd can have three very important type of conditions that can be available, okay? Hazards that can convert to hazards. One is the critical occupancy. When we're discussing about critical occupancy, meaning too many people in limited amount of area, okay? Like for example, whenever there's fireworks in near Burj Khalifa, so too many people, right? It's critical occupancy place, right? So whenever if God forbid there's going to be any type of hazardous situation, any type of emergency situation, okay, so there's going to be stampede, right? So for that purpose, the specialists have to work out so that how they can isolate people, how the emergency medical services vehicles are there, EMS vehicles are there, EMS teams are occupied, so they can control the situation. So critical occupancy means too many people in limited amount of area, okay, overcrowded. So that is critical occupancy, one of the hazardous situation that can occur in the crowd management, okay. The second one is the flight response. Flight response indicating that people, they tend to run away from a real or a fake threat, okay. You just hear a threat and you just want to run away. They don't know where the emergency exits are. They don't try to follow. They just run off into various different directions. Okay. So if I want to relate it, one of the incidents of Qutub Minar, okay, Qutub Minar incident, what happened? It's a historical place, usually visitors, occupied, evening time, suddenly a blackout occurred, okay. Blackout means power disconnection. Totally dark. Someone screamed a false information that the building is collapsing. So what happened? Everyone started running. A stampede situation occurred. Okay, 44 deaths. Okay, so that's a flight response, meaning either a real or a fake threat. Okay, you just hear the threat, you just run out of panicking situation. Okay, so this whole panicking situation, everyone running into various different directions. Okay, they just take off the flight simply. Okay, that's a flight response. The third occupancy is crowd hazardous situation can occur because of craze. When people, they tend to move on or they tend to push out towards the railing. Like for example, if any famous celebrity who is crossing by, so there are barriers, so everyone will try to move on closer to him, right? So what will happen? The force will be exerted directly on the barrier itself, right? And in case of a collapse of the barrier, everyone will fall down. So there will be injuries or even there could be deaths also. So for that purpose, what will happen that you will see that sometimes the security personnel, they are pushing the force backwards. Why? Because they want to neutralize the force. Okay, so usually we say they are very rude and they are trying to hit us or something, and they're trying to push us away. Basically, they are trying to neutralize the force so that a barrier is actually not breaking down. Once that barrier breaks down, okay, it will not affect them. They will move back. Okay, but it will affect the personnel, it will affect the crowd itself. So people will fall on each other, there will be a stampede situation, and then the people who are coming from back, they will start crossing them. So stampede situation may occur. So for that purpose, just to protect a barrier, they have to apply equal force backwards, okay, so that the barrier is not break. So that is a point of craze. So three important factors that can affect the crowd. Okay, whenever any type of a crowd situation occurs, in means of egress, your means of egress failure can be there based on three factors whenever you are managing the crowd. Okay. Let's discuss about the evacuation strategies. Okay, what are the different types of evacuation strategies and how they can be used accordingly? Okay. Evacuation strategies, three types of evacuation strategies are there. So the first one is total evacuation, most common one. Then we have partial evacuation. And in the last, we have defend and play strategy. Total evacuation indicates from the name itself, if there's a threat, the whole occupancy has to evacuate. Okay. The occupants from the whole occupancy has to evacuate. That is total evacuation. Partial evacuation can be further categorized into two types. Okay. One is zoned evacuation. Oh, sorry. One is delayed evacuation. Delayed or zoned, both are same. Delayed evacuation. Okay. And the second one is phased evacuation. Partial evacuation can be again further categorized into two, delayed or phased evacuation. Okay. So let's say if I have a high-rise building, okay, fire breaks out somewhere, let's say at the 15th floor. Okay, I have 70th floor building. If the fire breaks out at the 15th floor, okay, what will be my priority? The people that are first of all near to the threat, I need to evacuate them. Right? Means the people that are near to the threat, they will be evacuated first. Okay. It could be from 10th to 25th floor because fire always propagates upwards. Okay, so my priority will be upwards. Ground floor one people, they can be easily evacuated, means staircase distance is also less. So my priority will be, anyways, whatever strategies. That also changes with fire. Okay, about the air entrainment also. But anyways, anyone that, first of all, the people that are near to the threat, I need to evacuate without wasting any time. Once they have been evacuated, okay, what I tend to do, I tend to, without, as soon as they are evacuated, without any wait, I evacuate these people also. So my first phase is those people near to that threat. Without any delay, as soon as these people are evacuated, I move towards the other people and I evacuate them in phase. This is phased evacuation. Okay, without any pause. As soon as these people near to a threat are evacuated, the other people are also evacuated. Okay, why I'm saying this? Because the second point will define the delayed evacuation. Same situation, okay, 70 floor building. But here, what I tend to do is I have compartment rooms, refuge rooms, okay. Refuge rooms where you can, of course, take refuge for the time being, okay. So fire breaks out, same 15th floor. Let's say people that are near to the threat, they are evacuated. Now, unnecessarily, I don't require, because now this call can be made by the fire chief marshal who is outside. So he thinks that, okay, it's not going to propagate that much. Okay, he will just say that other floor people just move in towards the compartmented rooms. Don't need to evacuate, just move in towards the compartmented rooms. Okay, stay there and wait for further instructions. Okay, if they can cover it up, they will say return back to your rooms. If not, then they will say them to evacuate. So it's a delayed evacuation. Okay, there's a delay. Why? Because you want the people to wait in the compartmented rooms. Okay, means there's a delay there. Okay, so first phase evacuation, from the name itself, first phase, and then the second phase. Okay, so delayed evacuation, you allow them people to stay there in the refuge rooms, take refuge there. If there is no threat, they can return back to their rooms. If the threat is continuously increasing, okay, and sometimes it may allow firefighters personally for themselves to access the refuge room so that they can evacuate people, or they can give instructions. Yes, okay, 35 to 40 floor people, please evacuate now. So from the refuge rooms, they will take the staircases, they will evacuate. So usually in high-rise buildings, we have partial or delayed or phased evacuation. And why? What is the purpose? Because the occupant load is too much high. At one time, you cannot say 70 floor building to evacuate at one time. A stampede situation will occur in the staircase. So many people will be occupied. So in case, God forbid, some pushing is there, someone is injured, so a stampede situation can occur. So that's good result. Movement of the people can be slow. Okay, as I said, there could be healthy, there could be disabled occupants. So the movement could be fast or movement could be slow. So based on that, you have to evacuate. In high-rise buildings, you cannot always call for total evacuation. You have to go for delayed or phased evacuation. Then comes defend in place strategy, meaning the threat is not actually enough. Okay, so no need for evacuation, no need for panicking situation. The threat is very minor. Okay, and you can actually stay inside the buildings and we can take care of it, no problem. You don't have to evacuate. Okay, so we'll take care of the threat. It's not that much, but defend in place strategy is a very tough call. Okay, greenfield fire incidents, I think so, in Britain, 3 years back, 3 to 4 years back. Exterior cladding of the building started a flame. Okay, now exterior cladding, the basic code says, international building code, it says only one thing. Okay, that exterior cladding should be of 2 hours of fire resistivity. Okay, so flame starts, fire team approaches there, fire marshal makes a call. He says, okay, no problem. It does not require evacuation. It can be even easily, it can be controlled. Okay, so she made a call. Everyone stay inside the rooms, defend in place. Okay, no need to evacuate. Okay, within 15 to 20 minutes, the whole cladding started burning. Fire break out towards the balconies. Rooms are completely smoked up. Okay, so when they started evacuation, okay, it was too much delay already. So because of that, a lot of deaths were there. If you read a case study of the Greenfield fire incident, okay, you will identify a lot of deaths were there. Okay, so defend in place strategy is not an easy call. Okay, the first thing is that we usually discuss is the life safety. Okay, the property is not important. Let it be burned, damaged, or whatever. You have to evacuate. Any threat is there, you have to evacuate people first. Okay, so basically, case ran out and everything, and eventually it came on the call itself that it was a wrong call. Okay, the people have to be evacuated first, whatever the threat. Okay, so defend in place strategy is good in some areas, but it could turn into worse in some other areas also. Okay, there are some occupancies where we don't want the people to remove from the facility, like for example, a person who is in ICU room, okay, who is on critical medication, critical machineries. Okay, so hospitals, critical operation or critical areas, okay, where ICU rooms are there, they are well isolated. 3 to 4 hours of fire protection is there, so that they always have one strategy. Their strategy is not evacuation. The hospitals are always designed for defend in place strategy, so they don't have to evacuate. That is what their strategy is. Smoke barriers, fire barriers. They want all these rooms to be completely filtered, okay, from anything. So you will see that sometimes they have oxygen supply also, necessary oxygen supply that is attached. Okay, and this oxygen supply is attached directly towards the patient rooms. Okay, so hospitals, they may evacuate. I'm not saying it's not possible for them to evacuate. In worst case scenarios, they start evacuation also. In case of any type of worst case scenarios, they have 3 zones: first zone, second zone, third zone. First zone is negotiated, the second zone is still there. They start their first emergency process, personal supply phase. Okay, personal patient removal phase. If you remember, we have discussed about 4 phases. Okay, first phase is personal supply phase. The second phase is patient preparation phase. Patient preparation phase starts when your first zone is negotiated, means the flame has broken from the first zone and it's entered the second zone. Patient preparation is already there. As soon as your second zone is negotiated, the third phase starts. That is the patient removal phase. You tend to remove the patients. And fourth is the rest and recovery phase. So basic, but when the hospitals are designed, they are designed for defend in place strategy. They are always designed so that they don't have to evacuate. So they have very high fire resistive materials. Okay, they have good smoke, you can say, management system. Okay, so that they can, or they don't have to evacuate that area. Okay, so if in the examination also this question comes for healthcare occupancies, they're always designed for defend in place strategy. Where they don't want the people to, they don't want, because they already know that there are occupants that are on critical medication. So evacuation may affect other people. Okay, so based on the occupancy type, we change our evacuation strategy. Okay, like for example, let's mention some of the occupancies. We have assembly occupancy. Okay, detention and correctional facilities. Okay, like prisons. Okay, then let's say we have aircraft control tower. Okay. High-rise buildings. Okay. So if I want to define evacuation strategy for assembly occupancy, what type of evacuation strategy will be for the assembly occupancies? Among these three, which one will be applicable for assembly occupancy? Assembly occupancy is a place we usually define that 50 or more people are gathered at one point. Our movie theater, okay, cinema, it's an assembly occupancy. Okay, any type of conference rooms, okay, wedding halls, these all are assembly occupancies. So if there's a threat, what type of a strategy will be effective? It will be total evacuation, because all at the same time they are all equal in the threat, right? So it will be total evacuation. Detention and correctional facilities, prisons, what type of evacuation strategy will be effective?
Defend in place.
Two types of strategies can be there. Okay, either it can be defend in place. Okay, if the threat is not really nearby to that presence, but if it is near to that prison, then I want the people to move within the facility to a secured area. So it will be delayed, right? So both of the strategies can be applied: defend in place and delayed, right? If the threat is not near to those one, so they can stay there, whatever they are, wherever they are. But if the threat is affecting those area, so they can be moved within the facility towards a secured area, compartmented area. Okay, so defend in place or delayed evacuation. Aircraft control tower. Aircraft control tower. A person who is actually sitting there, and he has multiple aircrafts that are on the. He's handling multiple aircraft, right? So what type of evacuation strategy will be designed for this type of occupancy? We don't want a person, of course, to leave the facility. So you have aircrafts, yes. So it is always designed as defend in place strategy, right? You don't want the person who is in charge, okay, who is in charge of directing the planes for landing and take off. Okay, so you cannot allow him to evacuate from that area, right? So whenever the aircraft control tower type of facility is there, okay, they are always designed for defend in place strategy. Okay, worst scenarios can always occur. We are not talking about the strategy on which the basis on which the occupancy is usually built. Okay, high-rise buildings. It is partial evacuation. Phased or delayed depends upon the high-rise building's capability, whether it has compartmented rooms or not. As I said, that NFP101 focuses on both new and existing buildings. There are existing high-rise buildings that don't have any compartmented rooms or refuge rooms, right? But the nowadays new buildings, okay, they have compartmented and refuge rooms. Okay, so it focuses on both. So whenever we have high-rise buildings, we go for a partial evacuation. Whether it wants to go for phased or delayed, that will depend upon the construction element of the building. Okay, so that is how we tend to utilize the evacuation strategies. We tend to see that which type of an occupancy requires what type of an evacuation strategy. Okay, so three strategies, all three have different type of mechanisms in different type of occupancies. Okay, so the criticality of the occupancy defines whether you want the people to evacuate or whether you don't want them to evacuate. Okay. Okay. Sometimes in the examination, okay, they may twist the question, like for example, in total evacuation, partial evacuation, and defend in place. They may collaborate this one in section 1 also, safety in built environment. Safety in built environment is more related towards any type of hazards that are associated. Either it's man-made hazards, okay, either it's accidental like fire, burns, electric shocks, falls, or either it's natural disasters like earthquakes, cyclones, floods, okay. So they can collaborate that also. Like for example, they may ask you in earthquakes, during an earthquake, which type of evacuation strategy is effective? Earthquake. Earthquakes, total evacuation. What is the basic rule in earthquake? What they say, whenever there's an earthquake, hide under a table, right? Hide under something, right? So a defend in place strategy. Okay. So okay. So like this, they can ask in the examination. So they can twist. So maybe you are expecting from a occupancy point of view. Now they're talking about a natural disaster, like in cyclones. Okay. Defend in place, away from windows. Windows will break down. Okay. So like this, they can collaborate the questions. Okay. Let's take some questions from section 4, human factor and emergencies. Okay, guys. Okay, let's continue. Okay, question number 1. A study of NFPA recommended smoke detector noise level of. Yes. We have discussed this in 2 sections, section 14 and section 4. Start also. Section 4 start we have discussed. Smoke detector noise level should be how much? It is 75 dBA. Yes. B. A study of NFP recommended smoke detector noise level of 75 dBA. Okay. Next question. The decision model that occurs when the individual perceives cues that indicate a threatening fire. The decision model when the individual perceives cues that indicate a threatening fire. Yes. No, evaluation is the point where he is finding the way out. Here, there are cues that indicate the threatening fire, that is recognition. It indicate a threat is there. Okay. That is recognition, exactly. Okay. It is C. The highest behavioral activity in decision-making model is highest behavioral activity. And when we are saying highest behavioral activity, we mean by extreme stress. Exactly. It is the reassessment stage. Why? Because your evaluation has failed, right? So you have to again reassess the whole situation. So your extreme behavioral activity and stress level is high at reassessment stage. Okay. The time interval between fire ignition and the time at which conditions become untenable and occupants are unable to move to a location of safety is known as. Okay, let me give you a hint. No, it's not actually a delay time. Okay. Delay time will be the means it's all related towards the movement. But here, if you'll see the question, if you understand the question more carefully, okay, it's not talking about the movement of a person. Okay. Here, it's providing you an interval. Okay. It's providing you 2 different incidents. The first incident is that the time interval, okay, between fire ignition. The first time is the time that has having a fire ignition. And the second information that it's providing you is where the condition becomes untenable for the people and the occupants are still not at the location of safety. So it means that these 2 intervals, if you read them carefully, okay, so they are they are defining your 2 phenomena. Either it's the available safety egress time or it's the required safety egress time. If I want to define a delay time, then it has nothing to do with the fire ignition and the time for the occupants. Okay, it will be only focused on the occupants itself, that the occupants are having a delay to reach towards the location of safety. Okay, so here it's providing 2 intervals to you. So either it's A set or either it's R set. Okay. R set, no, R set is the time where it has already occupants have moved towards the location of safety. R set means the required time for the people to move towards the location of safety. So here it's saying a scenario in which the people are still unable to move towards the location. So the time that I'm going to make it available for them. unless they have not moved towards the location of safety. Okay, so that is available safety egress time. Okay, so once you read the definition, okay, it's the available safety egress time. Exactly. See, okay, which model detects heat and sprinkler activation? The model which detects heat and sprinkler activation is detect model, right? The detect model defines detection and activation of the sprinkler. Okay, next question. The time it takes an occupant to perceive the alarm or fire cue and decide to take action is? Exactly. The time to take action is? Means I have already perceived the alarm cue. Now, what type of action I'm going to take? Okay, whether I'm going to be super active, frozen up, okay, so whatever the time I'm going to take, how the panicking situation is going to overcome me. So that's the reaction time, right? Next question. The contents that are liable to burn, reaction time. The right answer is reaction time. No, travel time and pre-evacuation activity time, they don't define the action. Pre-evacuation activity time has already crossed the reaction time. Okay, means whatever the reaction, after listening to the notification, what is your reaction? That is the first thing, and then comes the pre-evacuation activity time. Okay, so means that here it's talking about how you perceive it and what is your action accordingly. Okay, so that is the reaction time. Okay, the contents that are liable to burn with moderate rapidity and give off considerable amount of smoke are hazard of contents. Okay, 3 hazard of contents are there: light, ordinary, and moderate. Right? Exactly. That burn with moderate rapidity and give off a considerable amount of smoke are ordinary hazard contents. Light hazard, they have no self-propagating flame. Ordinary hazard, they burn with moderate rapidity. And high hazard, they burn with extreme rapidity. Okay, so it's portion of means of egress that is separated from the area of building from which escape is to be made is known as? From where the escape is to be made. Remember the punch words. Where is the pathway here in the statement? Yes, there is no pathway here, right? The punch word. Portion of means of egress, I have already said that is separated from the area of building. Okay, that separates you from the area of building, or that is separated from the area of where, from where the escape is to be made. Exit access is defined as the pathway that leads towards the exit, right? So that is exit, right? So this portion of means of egress is exit A. It's exit. Okay, which among these are not considered as exits? And when we are saying, okay, they are not considered as exits, okay, so meaning that they are not considered as means of egress. Okay, so both A and B, windows, ropes, ladders, they are not considered as exits. Okay, they are not considered as means of egress. The situation in which people are fleeing either from a real threat or a perceived one is stated as?
Flight response.
Yes. Whether the threat is real or it's an imaginary one. It is flight response. The Qutub Minar incident, flight response. A real or an imaginary threat, okay, that is available, and people take action accordingly. The temporal 3 signal was mandated as the building evacuation code in NFPA. Yes. Yes. Sorry. NFPA 72. Okay. NFPA 72 mandates all fire alarm signaling code, fire alarm and signaling code. So everything is from NFPA 72. NFPA 72. And the next question, we have discussed this question in section 14 also. An alarm signal to noise ratio passing through a door will be reduced by? Hmm. Alarm signal to noise ratio passing through a door will be reduced by? It will always be reduced by 15 dBA. If you remember, we were discussing 75 dBA as a sound pressure level. So if I have a door, okay, or a wall, and I have a person there, so it means that there will be a reduction of 15 dBA. So I have to keep the sound pressure level 90 dBA. So that the loss is there, and then the person will reach, it is going to be 75 dBA. Okay. So door to noise ratio from either it's from door or a wall, it will always be reduced by, as a constant, we keep it around 15 dBA. Okay. The decision model described as cognitive and psychological activity required for an individual to respond to a threat is so we are cognitive, again mental and psychological, okay, activity required for individual to respond to a threat is yes, he's yes, he's already evaluating the whole situation, right? So when you're evaluating, everything is going in your mind, right? So your cognitive and psychological effect is actually has to be strong there, because in panicking situation usually most of the people lack in evaluation. Okay, they don't evaluate the pathways. People jumping in panicking situation, jumping out of windows, not knowing which floor they are, right? Because that is what they think is that is the best way. Okay, so evaluation, where you have to figure it out which way, which pathway you have to take for escape. Okay, so evaluation. Which among these is not considered part of delay time of evacuation time? Which is not a part of delay time of evacuation time? Read all the options. Which is not considered a part of delay time? Hmm. Hmm. When you start the travel, it's not delay. We have discussed this, right? Once you start your travel, it's not a delay time. So, which among these is not considered part of delay time of evacuation time? That is travel time. If you'll see, sorry, if you'll see in the evacuation time, what we did, delay time, we put the further three models: time to notification, reaction, and pre-evacuation activity. So all these are part of delay time, but the travel time was always kept aside, because travel time is not a part of delay time. Evacuation is equal to delay time plus travel time. So travel time is not considered as a part of delay time. Once you start the travel, it's not a delay. Okay. Three fundamental characteristics of crowd movement are No. Crowd movement. Focus. I provide two informations. One was the fundamental characteristics of means of egress. There, I will always have the corridor width available with me, right? In the means of egress, I was defining it that the question can be tricky. Here, I am talking about the characteristics of crowd movement. I am not talking about uh, the means of egress. Crowd movement, only focusing on the movement. We are not talking about the means of egress. So width will not be there. So any option that has no width. Okay. When I'm talking about the fundamental characteristics or I'm talking about the means of egress, there the width will be there. Understand the point, right? Then this is a trick question. Here, the fundamental characteristics of movement, right? The width has nothing to do with it. It has only the flow per persons per second, how much speed, okay, and how much area they are occupying. Yeah, that is the only place. Too much crowded area, your movement speed is slow. So people per second is also slow. Less area, okay, vacant area, your speed is more, right? Your density is less, your speed is more. Okay, so your people per second will automatically increase. So the three fundamental characteristics are speed, density, and flow, right? Of crowd movement. Okay. Next question. The measurement of degree of crowding in an evacuation route and is usually expressed in persons per unit area is defined as yes. In the formula, we had flow is equal to speed into weight into density, right? And we write that density is persons per square meter, right? How many persons in how many square meter it's being occupied, and from there we calculated the density, and then we calculated the flow, right? So persons per unit area is defined as density, right? Okay. Any point in a system where the character or dimension of a route changes or merges is known as so whenever in pipings in everywhere, wherever we have any type of a route that expands or merges. So what happens? Your flow is affected, right? So they are known as transitions. Okay. They are transitions. Okay. The type of evacuation model that generally handle large number of people in a network flow. Yes. Hmm? Which one? We discussed three models: capacity model, right? Movement model and behavior model. So large number of people we defined, that was movement models, right? It was movement models. Okay. The method for calculating means of egress, which involves evacuating a building within a specified maximum period of time. Hmm? Effective with method. Means of egress, calculating means of egress, which involves, okay, a building within a specified maximum period of time is flow method. Flow is equal to speed into weight into density. Right. Okay. For floor coverings, class 2 finishes has a minimum critical radiant flux of 0.22. Yes, that is 0.22. Okay, so You can see here, if there are some questions, okay, that are easy to answer. Okay, so if you'll go for the minimum critical radiant flux in the book, okay, so you have to go to the index. In the index, you have to find, first of all, you have to find out where the critical radiant flux is given. And then you will be provided with a reference. You go to the reference, and there you'll find out this answer. So how much time is consumed? So in the CFS examination, it's all about your time. Okay, how you save your time. Okay, it's all the thing, everything is all about the time, how you can save the time. Okay, it's you against the time. So 180 minutes, 100 questions. Okay, the best way is that you yes, the notes has to be shared. I didn't share the last week's notes. I will share the notes. So once the notes are shared, highlight the book, but you have to highlight yourself. You need to be familiarized with the book. Okay, it's not easy to memorize everything, but at least you should know. Your preparation should be that if a question comes, you should know that it is coming from section, which section this question is coming from. Any type of question related towards detectors, notification appliances, section 14. Any type of question related towards extinguishers, whether it's farm system, wet chemicals, dry chemical powders, carbon dioxide, it is section 17. Any type of questions regarding automatic sprinkler systems, section 16. Water supplies, section 15. Okay, any type of question regarding basics of fires, okay, which is not talking about any advanced methodology of technology. It's only asking you about some basic of methodologies. Okay, convection, heat transfer mechanism, measurement devices, this all will be from basics of fire. Okay, so if you can, the best practice is that of passing the examination is that if you can read a question, you can identify that I know this section, this question is from this section. It solves a lot of time. It saves a lot of time for you. Okay, so that is the technique that you have to implement it, and it's a very difficult practice, much more difficult than it is said. Okay, when you are yourself and you are highlighting the book, okay, it's going to take time. It is time consuming. So that is why when we are covering sections, it is very important that the lectures recordings, okay, you go through it, you highlight the book, make notes, your own notes, because what I am making, this is my understanding. What you will make, that will be your understanding, that what you have extracted from that topic. Okay, so like this, it will be easy for you to solve questions close book. Okay, so what now, how you have to pass in the first attempt, it depends on you. How many questions you will solve close book. The more questions you will solve close book, the more chances you are going to pass the exam. Okay, but anyways, it will be much more clear, but because we'll be taking some mock examination, like 70 questions we'll be taking during our preparation. We'll try to discuss those questions, okay, live, and then we'll see that how we can break down questions. Some questions may require you to break down. Like, for example, we are discussing about evacuation strategies. Now they can include natural disasters, and they can include that this percentage is from section 1. Okay, now technically, yes, section 1 has all the natural disasters, okay, earthquakes, landslides. So now these type of questions, that what type of evacuation strategy is more effective for earthquake, what you will search in the index. You'll go earthquakes will take you to section 1. Section 1, there is no evacuation strategy there. The evacuation strategy is in human factor in emergency, section 4, right? So basically, you have to prepare yourself accordingly. Okay, so some questions don't depend all the questions on the index. Some questions have in fact, all the questions are straightforward. Okay, so if you can break them, come back to the basics, you can easily solve these questions without opening the book. Okay, let's just take 10-15 minutes of break. We'll continue with towards facilities fire hazard management, okay, in which we are going to start from section 7. We will involve section 10 and section 12 also in it. Okay. So after break, we will start from section 7, that is storage and handling of materials, in which we'll discuss about storage of liquids, okay, gases, storage of chemicals, okay. We'll see the hazard identification marks, types of chemicals, okay. We'll see what we can cover today, okay. And then we'll be in this section, in this portion of the CFS examination, very important portion, okay, and very difficult also. Why? Because you have to memorize all these things. There's a lot of chemical names. Of course, we are not going to mention here. We'll just see the list. We'll go through the list. Okay, but whenever a question comes from regarding any chemicals, we have to come towards section 7 of the fire protection handbook. Okay, section 7 storage of chemicals contains all information regarding the chemicals, okay? Whether it's air reactive chemicals, water reactive chemicals, oxidizers, okay? Any type of corrosive chemicals, okay? So all these chemicals, all this information is available in section 7. So we'll just take 15 minutes for break, then we'll be back and we'll continue. Okay. Okay, we'll continue with facility fire hazard management. Okay, that is 15% of the examination. Okay, and it it collaborates multiple sections together. Okay, it's like section 7, section 10, section 12. Okay, they all are collaborated with multiple portions of section 6 also. So 3-4 sections are collaborated together. Okay, to give us 115% of the examination. Okay, so we'll start with section 7 today. Okay, that is storage and handling of materials. Yeah. In section 7, the most important thing is storage and handling of materials means it's going to include everything. Okay, it's going to include solid fuels, liquids, gases, and chemicals. Okay, and this section involves what are the storage practices that we are going to take. Okay, and when we are talking about storage practices, there are different types of tanks that may be involved. Like for example, we'll discuss about above ground tanks, underground tanks, gauging tanks. Okay, what are the cleaning procedures for the liquids? How the tank should be cleaned out? Okay, what type of liquids we can store? What are the hazards that are associated with each and every parameter? Okay, hazard associated with chemical, liquids, okay, gases when they are leaked out. Okay, so what are these hazards? How to control these hazards? Okay, so for that parameter, this section 7 includes everything. So whenever there's a question, okay, regarding any type of solid fuel like coal, wood, okay, so it will be from section 7. Any type of storage practice, okay, for liquids like flammable, combustible liquids, okay, you have to come back to section 7, because before understanding about the liquids, they have given they have provided us all the details on the flammable and combustible liquids. Okay, unless you don't know the liquid itself, you cannot store it, right? You cannot provide any protection for it, right? So for that parameter, you should understand about the liquids. So flammable combustible liquids, you will come to section 7. Gases, hazard associated with gases, you will come to section 7. Chemicals, any type of chemicals, if they're asking any information, like for example, they may ask you about nitrates, nitrites, okay, sulfates, anything if they're asking, you have to directly come to section 7. So all the information will be available here. Okay, so let's start from the solid fuels. Okay, let's start from the first topic, that is first chapter, section 1, chapter section 7, chapter 1. Okay, that is storage and handling of solid fuels. Okay. Solid fuels can be categorized into 2 types. Okay, one is coal and one is wood. Okay, whenever we are talking about solid fuels, it's usually coal and wood. Okay. Okay. Coal and wood, they both have very different characteristics. Okay. Like wood, it has the capability of releasing too much amount of smoke. Coal, that has a tendency to give off heat. So keeping these 2 characteristics in mind, where do we require the storage practice of wood and coal? Usually wherever we have steam turbines. Okay, so the heat that is generated from coal and wood is usually used in high voltage AC DC power plants. Okay, so where the steam turbines are usually required to run, so we have large quantities of coal and wood stored. Okay, for that parameter, we have to first of all understand that how we can store, what are the characteristics of coal. Okay, what are the parameters in which coal can go from stable state to ignition stage. Okay, how the coal can be stored, what are the fire protection measures, detection measures that we can use, and then which guidelines we have to follow to store the solid fuels. Okay, so all in all, we are going to start from solid fuels that sorry, from our coal. Okay, and then we'll continue towards wood. Okay, so first of all, let's start from coal. Yeah. And then we'll discuss about wood. Okay, so coal itself. Different types of hazards are associated with call. Okay, that can lead towards flash fires and dust explosions. Why? Because call, whenever it's stored, it tends to give off dust into the atmosphere. So that area needs to be ventilated. The second important parameter about the call is that it tends to give off carbon monoxide in the atmosphere. And carbon monoxide, we have already discussed, it tends to displace oxygen very effectively, right? So for that parameter, we have to define that how the coal can be stored and in which situation, in which form it should be stored. But before storing of the coal, again, we have to first of all identify what is the characteristic of the coal. The coal is not of one type. There are different types of coals that can be stored, right? So coal types start from anthracite, bituminous, subbituminous, lignite, coke. So we have all these types of coal that is available with us. Each coal type has different heat tending capacities than the other one. Okay, maybe the anthracite will be much more easy ignitable than the bituminous. Bituminous may have much more heat resistivity than subbituminous. Okay, what we are trying to derive from here is that whenever we are going to store coal, okay, the most important thing is that each type of a coal should be segregated. Okay, best storage practice for even chemicals, okay, for coal is segregation. Okay, if you can segregate among the types of the coal, okay, it will be much more easier for you to handle the quantity of coal because each and every one has its own heat tending capacities. Okay, now these are the coal that is used either for commercial cooking processes, okay, or they can be used for inside the power plants also to generate steam. Okay, now among the coal particles, okay, the most definite amount of the coal is the subbituminous coal. Okay, but the subbituminous coal contains large quantities of sulfur. Now, what does the sulfur does to the coal? The more quantity of sulfur, the more easily it can break down. Okay, it will be much more soft. The less sulfur, the more rigid, the more hard it is. Okay, and why do we need to know this property? We will discuss that later on also in the storage. But for the time being, the sulfur, okay, the more quantity of sulfur in a cold storage pile, okay, storage drum or storage tank, okay, the more quantity of sulfur, the more easily it can break down. The less quantity of sulfur, the more rigid it is, the more hard it is. Okay, subbituminous type of coal contains large quantities of sulfur, releases large quantities of sulfur. This sulfur, okay, when is released, when it reacts with the oxygen in the atmosphere, it gives sulfur dioxide. Okay, sulfur dioxide is also considered to be the prime cause for acid rain. Sulfur dioxide is considered to be the prime cause for acid rain. Okay, so in examination they can ask you indirectly, okay, prime cause of acid rain can be caused by which type of coal? Okay, it can be inversely like this. Usually when this question came in during my examination also, okay, I got tricked with this question. Okay, because my concern first time appearing, we were just going for the types of the coal. That was fine for us. Okay, later on in the paragraphs you will find out that it releases large amount of sulfur. Sulfur reacts with oxygen, gives sulfur dioxide, and it is caused as sulfur dioxide is considered to be the prime cause for acid rain. So indirectly it is subbituminous type of coal. So a question can go other way around also. Okay, so for that purpose, that's why we are discussing the types of the calls. Okay, okay, then we have the calls. Okay, what are the conditions under which the coal may get ignited. Okay, for that purpose, we have to know the spontaneous heating of coal. Coal heating or hazards that are associated with coal can be because of various reasons. First of all, the chemical nature of the coal. The chemical nature of the coal. Okay, amount of quantity of sulfur, we are going to discuss that. Okay, that is also going to cause large quantity of large propagation, flame propagations. Like bituminous has large, oh sorry, I made a mistake here. Bituminous has large quantities of sulfur. Sorry, bituminous has large quantities of sulfur. Okay, sorry. And it is indirectly responsible for acid rain. Okay, not subbituminous. It has less sulfur. Bituminous has large quantity. It releases large quantities of sulfur. The chemical nature, okay, of the coal. The first thing is the chemical nature of the coal. The chemical nature of the coal defines the coal's ignition. As I said, that each and every type has its own heat tending capacities. So if you are storing coal, the chemical nature is very important to understand that which type of a coal I'm storing. Okay, and what will be the heat resistive practices that I have to take. Okay, the second thing about the coal is that second thing that can start a propagation is air entrainment. Air is very important. Okay, if there is free air entrainment among the coal particles, the more air will travel between the coal particles, the more chances that it is going to start the heating process. Okay, and that is the air entrainment. Okay, that is the second thing. Third thing that can start the coal fires, okay, is any type of foreign materials like wood, grass, or any other material that may go enter into the coal pile. Okay, so any foreign materials. Then the moisture, if the moisture is accumulated in the coal silo, okay, what will happen? That moisture, it accelerates the oxidation process. So heat tending capacities will differ, which will actually start a heating process. Okay, so moisture accumulation. Okay, then if there is any temperature rise because of steam lines, steam pipelines going near or beneath the cold storage pile, or because of the ambient temperature, if there is a temperature rise, it will affect the coal's heating process. The coal may start to have a heating process. Then the storage practice of the coal. Okay, the storage practice of the coal is also very important. And when we are saying about the storage practices, there are two types of practice that can be done to store coal. Okay, one storage practice includes if the coal is stored in compact form, and the other practice is uncompacted form. One is compact form and the other one is in the uncompacted form if the coal is being stored. So what is the compact form? In the compact form, we usually have coal that is stored inside a silo that is crushed in the form of powder. Okay, and then it is stored in layers. Okay, that is the compacted form, means compacted, crushed into powder form. Then comes the uncompacted form. In the uncompacted form, we usually have coal of different sizes in form of shapes. Different sizes, different shapes, the coal is being stored. That is the uncompacted form. Okay, two ways in which the coal can be used to be stored. One is the compact form and the other one is the uncompacted form. So which storage is more vulnerable towards fire, compacted or uncompacted? Okay, the light is. Yeah. Which form? Uncompacted form, right? The uncompacted because it is more like in crushed form. Okay, so it's not available. Portion is not visible. So compacted form is in the form of layers, small powder form. So uncompacted in the form of big stones, right? So what happens that free air is entrained through here. Okay, air can be entrained directly throughout the coal form. what will happen? More air that can pass freely through the call particles, more chances that it's going to ignite up, right? Okay, let me do something for the light. Actually, this light is affecting the screen. Let me see what I can do with the light. The sunlight is coming on the board. No? So yeah, the online people there will be difficult for us to study. You have other this board? Anything that you can use it to block it. Thank you. Okay, that's clear. Okay. Okay. So we're discussing about a storage practice. Okay. So a call can be stored either in compacted form or uncompacted form. Okay. So the compacted form, okay, usually in powder, crushed into layers. Okay. Uncompacted form, usually in the form of stones. So free and air entrainment, the more air it can pass through, the more chances that it's going to get heated up. Okay. Yeah. Okay. Now the next point. Next point is presence of sulfur. Okay. And when I'm saying presence of sulfur, okay, what do I mean by that? It means that if I have a rigid amount of coal, big, okay, more quantity of sulfur, what will happen? It will easily break down into two. So if it breaks down into two portions, again, air will pass freely. So that is the danger that we always have by storing coal. If more sulfur means more portions will break down and more air can enter and pass through. Okay, so that is why large quantities of sulfur can also affect the ignition process, heat combustion process of the coal storage. Okay, coal. So based on that, the hazards that are associated with coal. Now, what are the methods in which we can actually control, if any of these methods, if any of the processes which has actually started coal fires, it becomes difficult for us to control it. Okay, coal fires may take up to 6 to 7 days. Okay, to control the fire. Okay, it may take up to 6 to 7 days with the most effective agents. Okay, but the important thing here is that whenever the coal is stored, we have discussed it's usually in silos. Okay, so tanks, big container silos. Okay, it's usually there. The coal is usually stored there. Okay, so let's say that if I want to provide any type of an extinguishment for coal, or let's say firefighting, okay, for coal, so what agents I can use on coal fire? Remember one thing, okay, that I have coal that is usually stored in silos. Okay. So each silo has its own volume. So if I want to provide an extinguishing agent for a coal fire, what will be the agent? Yes. Which agent is more effective on coal fires? Which agent? Water, dry chemical powders, whatever agents we have discussed, carbon dioxide. Okay, forms. Yes. Water we can apply, but water is not considered a right agent for coal fires. Water is a wrong agent. Whenever you are talking about water, it's a wrong agent. Okay. And why we usually say water is a wrong agent? Because water converts to steam, and that's why that is the only purpose I was saying that volume has to keep in consideration. Okay, the tank has a volume, right? So when you apply water, steam is generated. Steam occupies larger volume. Internal pressure of the tank is going to exceed, which will result in vapor cloud explosions. Okay, so that is why water is a wrong agent. Okay, yes, we can use foam and we can use carbon dioxide. Okay, anything that can, first of all, call it heats up. So anything that can absorb heat, anything that can displace oxygen, because majorly oxygen we want to displace. Okay, air, we want to displace oxygen. So air, dry air is the most oxidizing agent that is available. So oxygen and cooling effect, these two are required to be removed. Foam systems do that. Carbon dioxide vapor does that. And nitrogen also does that. Nitrogen is a cold gas. It can absorb heat and it can also provide cooling effect, right? It displaces oxygen because its availability is 79% in the atmosphere, right? So it can easily displace oxygen, right? So these are the three effective agents that can be used. CO2? Yes. Sometimes what happens that they tend to spray carbon dioxide, okay, from a distance, okay, using towers, like, like you have water towers. Similarly, they have hoses, long hoses laid on vehicles to spray it, okay, over there. But it occupies larger space. Yes, it occupies larger space than the nitrogen itself. They don't want to use CO2. Actually, CO2 is effective, but they don't want to use CO2. Okay, CO2 has further effects. Actually, not only it displaces oxygen, okay, but it creates a type. Displacing oxygen means, dry air. You have 2179. You introduce CO2. What you are going to do is that you are going to remove oxygen, displace oxygen. Oxygen is displaced. What the nature will try to do? Nature will always try to balance out. So a pressure gradient is created in that area. Got a point, right? So it has to bring that oxygen. So that pressure gradient is not actually effective for environment as well as for human beings also. So sometimes we are saying that carbon dioxide is sprayed there. It's not dangerous to me here. It's not like that. Okay, the pressure gradient is created and it can affect that whole area. That is why we tend to avoid CO2. We don't want to use it. Okay. Okay, so the codes that we tend to follow, okay, for coal protection is NFPA 850. Okay, NFPA 850. That is actually the code or guideline for high voltage AC/DC power plants, because that is the only place this much amount of coal is stored. Okay. Okay, now when the coal is stored, it gives off toxic gases, as we discussed, carbon monoxide, sulfur. Okay, and coal is one of the challenging factors in such a way, because it means that if it is stored, we need to have an appropriate detection also, to make sure that we can detect any type of a hazard situation and we can try to take necessary precautions accordingly. So for detection of coal, what are the types of detectors we can use here? Yes. What type of detectors we can use? But remember one thing, in the coal, the most important thing is not the surface temperature. The surface temperature is not important, right? The temperature at the bottom of the coil is much more important. Because if the temperature at the bottom is high, because the heat is going to start from here. If the temperature is 57 on the surface, it means bottom has already reached 100. Okay. So if you want to detect heat at the very initial stage of a coil, okay, so which type of detection mechanism you'll use? What type of detectors you'll use? Methane and CO is the type of detectors. Yes, we will use CO detectors, carbon monoxide, because we have discussed carbon monoxide will be released. Yes. So one of type of a detector, we can say yes, one detector is carbon monoxide detector. But carbon monoxide detector, okay, is for toxic to monitor the carbon monoxide concentration. If it reaches above value, so we want appropriate ventilation. Yes. Okay. Other detectors that we can use. Smoke detectors, no. Smoke detectors will always have a false alarm, because we have discussed whenever the core is short, dust is released. And where the dust will go? It will always go towards the ceiling. So ceiling means it's going to have a wood. Even in the wood cutting area, we don't use smoke detectors. Wood dust is going to falsely activate it. Dust anywhere is going to falsely activate the smoke detectors, right? So that's why we don't use. Linear heat is one of the most appropriate answers. We use linear heat detectors. Okay. One of the examples of a linear heat detector is also thermocouples. Okay. We use thermocouples, okay, that are approximately 3 feet in long. Okay. And we use it at the bottom of the coil. We tend to place them at the bottom of the coil. Okay. So when the heat rises at the bottom of the coil, okay, we tend to get an identification, okay, from the thermocouples. If you remember basics of fire and science, right? Temperature measurement, 4 ways we discussed. Okay, nowadays we usually say that it's a linear heat detectors, and thermocouples is actually the type of a linear heat detection. Okay, so what happens? Heat rises, voltage is induced, and a circuit is closed, right? So thermocouples can be used to measure the heat rise. Okay, remember one thing: coal surface-based heat detectors are a failure. Surface-based heat detectors are a failure for me. If surface-based heat detector means that the temperature here has to be 60, 65, heat will rise, then it will reach 57. At the bottom, it's already 150. So it means at the time when I'm getting a detection, the surface-based detection is already failure. So I don't use surface-based detection here. Okay. So that is why now we jump back to section 2, temperature measurements. What are the techniques that we have discussed? 4 measurements. Liquid expansion cannot be used here. Bimetallic cannot be used here. Thermocouples and pyrometers for radiation. So we have to go back to the basic and we have to devise what is the solution that is available with us. Okay. So we use thermocouples. Okay. Third type of a detector, we have also discussed various toxic gases are released like sulfur and other toxic gases may be released. So to detect toxic gases, which type of a detector we use? Yes. Toxic gases. Yes. Go back to section 14. We discussed detectors, gas detectors mechanism. One detector was used to measure any type of toxic gases. Radiations in section 2 also we discussed. To measure toxic gases. No one? Toxic gases, gas detectors, right? Which type of gas detectors? We discussed 3 types, right? Semiconductor. We discussed about catalytic element, and we discussed about the third one, that was infrared absorption principle. Infrared passes freely through diatomic symmetrical particles. Oxygen and nitrogen, it will pass freely. As soon as any monatomic asymmetrical particle will enter, infrared is going to get absorbed. So infrared detection is used widely for our toxic gases. So infrared monitoring. Okay. Fourth, Even though in the coal, the base is very important, but we can never neglect the surface temperature. But a surface temperature, how to measure, right? For a surface temperature, I cannot have surface heat detectors. For that, I will go for thermography. Usually, you'll see that we have these thermographic glasses that continuously gives us the body temperature, right? Like a blue, orange color, and the more the orange, then we know. In solar panels analysis, we usually see thermography so that we know which solar panel is conducting more heat and which is not conducting. If it's not conducting, we tend to replace it, right? So thermography that continuously gives the surface temperature of the coal silo. So it's not only one detector, we use 4 detectors for 4 different purposes. So one of the most challenging factors is coal. If you want to store anything, okay, the most challenging factor, okay, is to store coal. You require a very controlled environment. Ventilation, appropriate ventilation is required, okay? And you cannot store coal for an extended period of time. You have to utilize it. So that is why the coal, whenever it's stored for extended period, it can start from moderate combustion to flaming combustion. Like a very high combustion stage can take any time. So that is why whenever the coal is stored, it's stored from the top, utilized from the bottom, right? So that the coal is not, no type of coal is stored for extended period of time. Okay, that's why it is stored from the top and it is utilized from the bottom. Okay. Okay. So this is for coal. Let's move on towards wood. One more information. Whenever we're talking about coal silo, okay, so the coal silo usually requires weatherproofing. Okay, why? Because we have discussed the external temperature can play a very important role for the storage site. Let's say storage site requirements. Certain requirements are there whenever you are going to plan or select a storage site for a coal. Okay, the first thing is that you have to make sure that a silo is protected by ambient temperature, the surrounding temperature, right? So for that purpose, what you want the coal to be the silo to be coated with the weatherproofing. The weatherproofing that is usually used for the coal is road tar. One of the most economical and most used method to protect the silo is road tar. Okay, you provide for the exterior so that the temperature, ambient temperature, is not having major effect on the coal. Okay, second thing is that whenever preparing the site, we have to make sure the nearby there is no any type of you can say agriculture products like grass, wood, vegetation is not there. Okay, far from vegetation. Okay, then streams and rivers. Why streams and rivers? Why far from streams and rivers? Hot weather, what happens? Water gets heated up. Around the surrounding air becomes moisturized. And we've discussed moisture. We don't want that to be accumulated, right? So moisture accelerates the oxidation process. We don't want that. Okay. So any type of steam lines like hot pipelines, okay, should not be traveling near towards the silo. That may heat up. Okay, so these are some very important parameters that they can ask you in the examination. They may ask you like weatherproofing. Weatherproofing for a coal silo can be done through, they can give you 4 different options. So it is the most economical method is road tar. Fire protection handbook defines road tar. Okay, so there are other methods also that you may find out, you may study, you may find very informative, but still we are going to follow the handbook, and it has mentioned road art to be the most economical method, okay, for weatherproofing. Okay, far from vegetation, far from streamlines, far from streams and rivers. Okay, so that is how you tend to prepare the storage site for the cold storage. Okay. Okay. Moving on towards wood. Wood again has wood can be used as a flash fire. Okay, it can be used as a flash fire. Wood can also give wood dust, which can also result in flash fires. Whenever we are going to protect the wood, okay, there are two things that we have to keep in concentration whenever we are storing wood. Two things that I have to be that can make wood vulnerable towards fire. The first thing is that in coal, we were saying moisture accumulation is dangerous. In wood, lack of moisture is actually dangerous. Okay, the more moisture wood, the more chances that it's going to survive for longer. More dry wood, more easily it will start the flame process. Okay, so reduction in moisture. And the second thing is reduction in size. Okay, size of the wood. Sometimes wood is stored in the form of logs, chips, raw form of different sizes. Okay, so it can affect the size of the wood. The larger the size, the more it will have the capacity to resist. The smaller the size, more quickly they will tend to burn up, because the heat attenuation per unit of an area for a chips, small sizes of wood is far more greater than the large wood, right? Then wood that is stored with or without bark. Bark, what is the bark? The brown structure on the exterior of the wood, right? In the forest woods, you'll find there's a hard brown structure. Okay, and it has the capability to resist heat for a considerable amount of time. So if the wood is with bark, it will take time. Okay, without bark, okay, it will tend to quickly ignite the flame. Okay, so reduction in size and reduction in moisture, these both can affect the wood's capability. Okay, so if I want to use agents, which agent I can use for wood fires? Water. Simple, right? Water is used very effectively, right, on wood fires. Okay. So for that purpose, if I'm using water, okay, so which codes I will follow for wood? Okay, so I will follow similar NFPA 13, NFPA 15, NFPA again 850. Okay, so these codes I will follow. Okay. What about detectors? In which storage area? What type of detectors I can store? Dust, smoke detectors, false alarm. Actually, we have seen a lot of installations. Personally, I have experienced one of the installations in one of our projects. Okay, wood cut, furniture industry. They're cutting wood. They're making furniture. In that area, they install detectors, smoke detectors. After every 2 minutes, 3 minutes, that detector is running. Okay, consultant approved. Everything approved. Drawing is there. Okay? But the false alarm ratio is very high. Eventually, what happened? Okay, they came for inspection, they passed the drawing, everything passed, continued running. And after 3 months, when we went there towards the facility to do the first maintenance, we found out the panel is off. Owner has kept it off. He's saying after every 2 minutes, I cannot bear it. Remove your device. My people, they are disturbed. We don't know what is going on. After every 2 minutes, it's triggering the alarm. Eventually, civil defense then reviewed the drawings, then changed the drawings. I think, okay, send it back to the consultant and install heat detectors. So one of the detectors that we tend to use in the wood is we don't have option. We use heat detectors. Okay. The other option can be flame detectors. But the flame detectors, when we are saying flame detectors, the false ratio is very high. Again, same as smoke detectors. Okay. Because when you are cutting woods, okay, so various machinery is running. So your IR detectors may tend to get triggered. Okay, ultraviolet detectors, they don't have that much amount of pathway. They travel less distance, more expansion. So for that purpose, it becomes more challenging. So usually we go for the most common type, that is heat detectors. Video detectors will not be effective. Why? Because dust is going to accumulate a shape. Okay, whenever it's going to accumulate a shape, so video detectors will just start taking pictures of the shape. Okay, and then it will send it back to the system. And if there is any type of 70% comparison, it will again trigger the alarm. So where the dust is there, okay, it becomes difficult. Video detectors are only effective in those areas where you are shutting down the facility. In daytime, you switch off the video detector, okay, because you are working. In evening, when you are about to close everything, all work closed, everything closed, okay, then you activate the video detectors, you shut down the shutter and you go. Okay, so video detectors are effective up to that point. In daylight, okay, there will be too much false alarm, especially where you have dust, either coal dust or wood dust. It will always give structures. Wood will give structures, dust will give structure, coal will give structures. Dust itself is going to accumulate any structure, and dust itself, what happens that when it collides with any partition, it converts into a structure. So that structure will be taken by the video based detectors. Nowadays, there are various types of intelligent video-based detector that has the capability to actually differentiate between the dust as well as between the smoke. Okay, so they tend to, because smoke, when it is actually being released from the material, it has a specific pattern. Okay, the source has a pattern. Okay, and afterwards the smoke particles, they tend to spread out. So they from the source they have a specific pattern. Dust from the source, they don't have a pattern. Dust, whenever it's going to raise up, it will always have a random pattern that it's going to rise up. Smoke has a specific pattern from the source. So that it usually differentiates. It has an algorithm that can differentiate between the smoke particulates based on the release pattern and the wood. But that again is a I mean, it's being used, but what are its effective ratio? We still don't have any record on that. But they say that it is much more effective. Okay, so sorry. So detectors that we tend to usually use heat, and we can use flame detectors. Yeah. Storage of liquids. Okay. So when we're discussing about liquids, again, either it's flammable or combustible liquids, right? Or any type of chemicals, it could be categorized. Okay, so we have, in the previous lectures, we have already defined class 1 liquids, class 2 liquids, and class 3 liquids, if you remember. Okay, 22.8 to 38 degrees Celsius is class 1 liquid category, 38 onwards to 60 degrees Celsius class 2, and from 60 to 93 degrees Celsius is class 3 liquids. Okay, so basically this is how we tend to differentiate, means the flash point differentiates between the flammable and combustible liquids, right? So whenever we are storing a liquid, okay, there are certain measurements that there are certain important parameters that we have to first of all define. What are the tanks that we can use? So we'll discuss about the above ground tanks in which I can store my liquids. Okay, above ground tanks are usually, okay, first of all, the construction element and the above ground tanks, they are defined in NFPA 30 guide for the stationary tanks, right? Above ground tanks are usually constructed of two materials. Okay, the construction materials are two. Either it's made of concrete or steel. Both have very good heat rending capacities. Concrete itself and steel, they both have very good heat rending capacities, heat absorption capacities. Okay. The tanks, they are usually protected by various types of devices, okay, so that in case of any type of hazardous situation, okay, the situation can be controlled. Usually the major portion is that whenever you are going to pour liquid into a tank, what is going to happen? Okay, whenever the liquid is being poured inside the tank, okay, whenever either it's water, any type of liquid, where you're going to pour inside the tank, what will happen? Vapor will accumulate. Okay, that's why they usually say don't completely full your car tanks. Why? In hot weather? Why? Because whenever you are going to pour, leave space for vapor. Okay, leave always space. Whenever the fuel is tackled, that's it, enough. No need to completely fill your oil tanks, right? Sorry, your car tanks, petrol tanks. No need to fill them. Why? Because you have to leave space for vapor. Whichever liquid you are going to pour inside a tank, vapor will accumulate. Okay, that is one of the basic concepts that you have to always keep in mind. Okay, and this vapor accumulation is how much space you have to leave. Okay, that also depends upon the type of the liquid, how much vapor accumulation will be there. That is why whenever dispensing of liquid is there, it has a specific pressure. Okay, based on that pressure, you will always identify that how much vapor accumulation is there. Okay, and for that purpose you need to vent out. So it's not like that I'm just going to keep a liquid inside a tank. I need to make sure that all these concentrations are always there. For that purpose, the first device that I want to use is venting and flame arresters. On the tank, okay. Whenever you are going to pour it, okay, vapor is accumulated. Remember one thing, each and every liquid has its own viscosity. Okay, sometimes you will see that a liquid at a specific pressure, whenever it's being transferred, friction occurs, electrostatic charges accumulate, and what happens? Spark, flame. But actually what you're doing, you're only just transferring liquid from one tank to other tank. Other than that, you're not doing anything else. So from where the flame accumulated, right? So basically, the pressure at which the hose and nozzle is dispensing the liquid, it accumulates static charges are there. And this electric static charges can create into spark. If at that point, the charges that are accumulated has exceeded the threshold limit of the material, spark will accumulate. And that spark may start a flame. With a flammable liquid, it will start, or flammable vapor, it will start a flame. There, okay? I'll explain you. Venting, what venting is doing, whatever you are going to, vapor will accumulate, it will open up, allowing the vapor to release. But it doesn't solve the problem. Flame, once your flame starts during dispensing, what will happen? Whatever accumulated vapor is there, it's going to blow it all up. So you need a type of a process in which you can actually control the flame. That is where the flame arresters come. Okay, means whenever a flame is being generated, it has to be absorbed somewhere, right? So flame arresters are usually, they are small type of fences that are installed, okay, in the you'll see that some type of drums when you're pouring a liquid, okay, so this a type of a fencing usually that is attached to the tanks. Major big tanks you will see they have permanently fixed fencing there. But the purpose here is that whenever a flame appears, okay, heat absorbs throughout the hall. It takes heat and it distributes over the fencing. So what will happen when you remove heat from flame? Fire comes, you remove heat. What will happen? Heat is directed towards the fencing, arrest. Flame is vanished. So it protects you against the static charges. Static charges, any flame that appears, okay, it will protect you from that. But it is not the only protection that you require. You need to provide grounding also. If you'll see, remember we were discussing in section 17, high pressure gas, whenever it releases, static charges are accumulated and you need to ground all the nozzles. Similarly, you have to ground the tank. So there are static charges that are accumulated or grounded appropriately. Okay, so appropriate grounding should always be provided. Okay, so the first important component is having venting and flame arresters. Okay, moving on, the second thing, sometimes what happens that you are actually keeping the liquid stored for a comparatively long period of time. Okay, and based on that you are extracting liquid also. So when you are extracting liquid or you are pouring liquid, vapor is accumulated. Okay, but you never know that you can I mean, under various mechanical refrigeration or mechanical systems, you cannot always maintain the pressure of the tank. The pressure of the tank will always change. Okay, constant pressure cannot be maintained. There could be situations where the pressure will always fluctuate. So for that purpose, okay, sometimes you require pressure relief devices. Okay, so that whenever the internal pressure of the tank exceeds, okay, your pressure relief devices, they will bleed off the pressure. For that purpose, you usually install pressure relief devices on the top of the tank. Okay, so pressure relief devices can be of two types. PRVs. One is the rupture disc type, and the second one is the pilot type. Okay. Rupture disc type, from the name itself, it's actually a disc. Okay, it expands up to a certain limitation and then it blasts off. Pressure is released. Okay, so it expands and then the pressure is released, and then you have to remove that disc, you have to put a next disc. Okay, that is the pressure, that is the rupture disc type. The second type of a pressure relief device is a piston type. Okay, pressure increases, spring contracts, valve opens, pressure releases, pressure decreases, spring expands, close the valve. So that is pilot operated type. Okay, so that is for the pilot operated type. Okay, so two types of devices are pressure relief devices are there. Okay, then most of the failures of the above ground tank is because of the collapse of foundation and supports. Okay, so foundations and supports in case of fire incidents. Okay, the fire incidents majorly is because of the foundations and supports. Okay, this failure results in the tank to collapse. Okay, so for that purpose, what NFPA3 recommends, NFPA3 recommends that all the foundations and support, they should have minimum of 2 hours of fire resistivity. Yes. Yes. Or each and everything. And the notes are all from the book itself. Yeah. Yeah. That big book, na, you will, when you start a highlighting, na, That is why only we are taking some chapters, no? Some topics we are taking. Each and every topic is not part of exam. So the notes that I'm handing over, na, so when you will highlight the book, you will know which chapters are there. All chapters are not part of exam. All chapters are not part of exam. Okay. So whatever we are discussing, just highlight the book accordingly. So you will know that what are the sections. The discussions are based on the chapters that we are covering. Means whatever the chapters are included, we're discussing those chapters only. Okay. Now this is important part of facilities hazard management. So when you see that is 15% of the examination. Okay, foundation supports, they should have 2 hours of fire resistivity so that in case of fire it does not collapse. Okay, then what about a leakage? If there is any leakage in the above ground tank, you don't want a liquid to be spread out throughout the facility, right? For that purpose, this leakage of the liquid should be in drains. Through drains, it will be collected in the dikes. Drain is there, and then you have a big pit hole, right, where the liquid is collected. You don't want the liquid to spread throughout the facility. So drains and dikes are there. Okay. Okay, so the above ground tanks, these are for the above ground tanks. Okay, usually there is only very minor difference between the above ground and underground tanks. Usually all the things are same, like venting arresters, flame arresters, special relief devices. The major difference between above ground and underground tank is the corrosion factor. Underground tanks, they have usually the corrosion factor. For that purpose, the construction element is different. They usually have fiberglass, plastic clad steel construction. Okay, and for corrosion, you need to have any type of cathodic protection system. We'll discuss about underground. But anyways, this is for the above ground tanks. Okay, so we'll just end the session here. Okay, so in the next session, we'll continue from here. We'll continue underground tanks, and we'll discuss about gases, okay, chemicals. Then we'll move on towards section 10, and hopefully in the next section, okay, we'll take a collaborative questions from all these 4 sections. Okay, and then we'll add some previous questions also, as I was saying. Okay, so we'll collaboratively discuss 70 questions. These all 3 sections will continue complete them, and then we'll go for the questions. Okay, okay, so we'll just end the session here. If you have any questions, you can ask now. If you go step by step, right, you take them on highlighting. Okay, so the important thing you do is it's already clear on the book. The note of the book, some notes are shared, some are in share notes. This cannot prepare for exam unless you don't know what is the thing. Okay? So those notes are there. The notes are there. Use those notes to identify the section. Okay, then you will know what are the, then you will, the first step is first step. That you have to take, you have to identify, then highlight, then familiar. That's a very good question. Okay, and these are the questions, these type of questions are good. Normal calculations and all the storage and all. Only thing is how to convert it Use to not highlight. Okay. Look, as a
total 20 chapters are there in the book.
21
chapters.
Okay, remember, all systems are not part of that. In the first section, I would say, first of all, you have to identify the slip. What is the slip? Okay. And how you will identify the slip? Follow the lecture, follow the note. You will know the slip, and you will highlight it. Okay, because if you, I mean, it's all based on the time that you have already had. You have lecture on Saturday, you have 6 days. 6 days, highlight it, identify it. First thing is first, you have to highlight it. Okay? And that you have to do by yourself. That is the only thing. A lot of students are passing very, not even though a lot of students from one same company have passed. And they used to say that we have 15, 20 minutes for review of the exam. So either it could be multiple trials or either it could be one. The first step is first step. Take note, go through the lecture, highlight it. That's the first step. Second step, okay, then moves on that once you are familiarized with the book, second step, then try to use the questions that we are using here and try to solve them closely. Try to solve them closely. That is the second try. There are 100 questions and then you have to solve them 3 hours.
2 minutes.
Less than 2 minutes. So basically, just keep in mind that you have a minute to solve something. Keep like that in mind. So how, I mean, it's not possible. If you're thinking you're going to open the book for every question, it's not going to go. It is never possible. We have to follow the same pattern.
So first we have to highlight the books, lecture, and then start narrating.
Highlight the book. Okay. Take note. Highlight the book. Go through the lecture. When you're hearing the lecture, just read it out. Correct me if I'm wrong. And like that, right? See, okay, where he has extracted this information. Where it is available. Find it out. Okay? Once you do that highlighting, then go for practice question. And practice question, if you don't know the close book answer, that is one thing. Okay? But remember, the second thing is that at least you should know which section the question is. That helps you. Half of the time it will say you don't have to go to the index and a lot of people say no, index is very good, index is very good. A lot of why the failure rate is high is because a lot of people follow it. 70% of pass. Okay. 70% of pass. But again, the index, don't depend on the index too much. Index you can highlight it, okay, but you cannot totally depend on the index.